কি হলো?
দাঁড়াও দাঁড়িয়ে যাও হ্যাঁ, এবার শুরু করো।
ওকে, ঠিক আছে।
হ্যাঁ,
গুড ইভিনিং everybody. Honorable Officer in Charge, Sister Nivedita, Government General Degree College for Girls and Chairperson of the webinar, eminent speakers, distinguished participants, respected coordinator of the IQAC, and my fellow colleagues and ladies and gentlemen. It is an honor and a privilege for me to greet you on behalf of the organizing committee to the first international webinar in our college on the emerging pandemic crisis, physiological and socio-environmental imperatives, which has been organized by Department of Physiology in association with IQAC, Sister Nivedita, Government General Degree College for Girls, Calcutta, West Bengal, India. I wish to extend my deep gratitude to the Honorable Chairperson, Dr. Tapas Bhattacharjee, Officer in Charge, Sister Nivedita, Government Degree College for Girls, and her constant support and encouragement to success this international webinar. I also extend my deep appreciation and heartfelt gratefulness to my sir, respected Dr. Sanjit, Professor and former Head, Department of Physiology, University of Calcutta, and to my friend, Mr. Tapas Bhattacharjee, WBCS Executive Officer, Deputy Commissioner, Howrah Municipal Corporation, and Professor Dr. Soumen, Professor, Pathology and Laboratory Medicine, Institute of Reproduction and Perinatal Research, Kansas Medical Center, USA, for their valuable presence in our webinar. Apart from them, Dr. Sharadindu Chakraborty, Coordinator IQAC and Chief Advisor of our webinar, Dr. Indrani Chakraborty, Convener of the webinar and Head of the Department of Physiology, Dr. Shormista Chandra, Convener, Dr. Bholanath Pakira, Member of the IQAC, and Sheikh Jahiduddin, Assistant Professor of Physics, are also present here. I greet you all once again to the webinar and hope that you will have a great time ahead. Thank you all. Now, on behalf of the organizing committee, I would like to request Dr. Shormista Chandra kindly to moderate the event. Please, Shormista, carry on.
Okay, Asumi, thank you for introducing me. Now, I'll extend my gratitude to everyone. Now, good evening once again to our respected speaker, Professor Dey and Professor Pal, Mr. Tapas Bhattacharjee, respected officer in charge, Dr. Tapas Bhattacharjee of our college, Sister Nivedita Government General Degree College, IQAC Coordinator, Dr. Sharadindu Chakraborty, Convener, Dr. Indrani Chakraborty of the Secretary, Dr. Atanu Saha, Dr. Bholanath Pakira, and Professor Sheikh Jahiduddin, and our respected audience. In this auspicious occasion, now I am inviting our beloved OIC Madam, Professor Dr. Tapas Bhattacharjee, to deliver her valuable speech to encourage us and to initiate this program. Please, Madam, you can join now and deliver your speech now.
Okay. Our respectable resource persons, Head, Department of Physiology, University of Calcutta, and former visiting scientist, MD Anderson Cancer Center, Houston, USA. Sri Tapas Bhattacharjee, Deputy Commissioner of Howrah Municipal Corporation. Professor Dr. Soumen Pal, Professor, Pathology and Laboratory Medicine, Institute of Reproduction and Perinatal Research, Kansas Medical Center, Kansas, USA. My esteemed colleagues from my college and other institutions, and my dear students. I welcome you all to this international webinar on the emerging pandemic crisis, physiological and socio-environmental imperatives, organized by the Department of Physiology in association with the Internal Quality Assurance Cell of our college. Surely we are going through one of the darkest periods of human history. The only way to see the light of hope in this darkness is to remain informed, to acquire continuous knowledge, and to behave in a wise manner. In this era of social media, we are always getting information through Facebook and WhatsApp. But how much of these are true? Are they really reliable? We sometimes find out that the news that took me yesterday was a fake one. The story that brought me on the verge of tears the day before yesterday is only partially true. And most dangerously, the advices that keep flowing on social media to keep safe in this pandemic situation are sometimes not to be practiced at all. So we are in search of proper knowledge. We, the layman, are in utter confusion and have so many queries. To give some examples, it is being said that statistically it has been found that persons with A positive blood group are more prone to be attacked by COVID-19. Again, it is being said that persons having deficiency in vitamin D succumb more to the disease. But we want to know, are there any clinical basis to these claims? It is now an established fact that most of the people who are affected by the disease are having mild symptoms like common cold and flu. But some cases are getting serious. Now, how am I to know just how my body will react if I get contracted? Again, if I get contracted once, is there any chance that I will be contracted again and with serious symptoms? There are some questions and confusions which keep on tormenting us. We are also worried about the local situation. We want to know how the administration is managing this crisis. With all these queries in our mind, we have organized this webinar. We are eagerly awaiting to listen to our internationally famed speakers. And I do hope this webinar will bring the light of knowledge and remove the darkness of ignorance from our mind. Thank you.
Sorry.
Thank you very much, madam.
Bholanatha, please send me the YouTube stream link. Bholanatha, please send me the YouTube stream link in WhatsApp. Oh.
Zahir, any problem here? Is it functioning properly? Is it functioning properly, Bhola? Okay, thank you, madam, for your inspiring speech. Now it's the time to enter into the core session of our webinar. Now, may I request Dr. Indrani Chakraborty to initiate the program of this course session and welcome Professor Dr. Sanjit De to deliver his speech. Indranidhi, am I audible to you?
Yeah.
Indranidhi?
Good morning to our international speaker and participants, and good afternoon, everybody. It is my pleasure to welcome all the participants from different parts of India as well as abroad to this international webinar. I welcome to all members of the organizing committee, our chairperson, honorable officer in charge of this college, Dr. Shivanti Bhattacharjee, who encouraged us to organize the first international webinar in this college. I welcome to the organizing secretary, Dr. Atanu Shah, and convener of IQAC, Dr. Sharadendra Chakraborty, and all members of IQAC. I also welcome to our faculties who helped us in technical level, Dr. Bholanatha, Sheikh Zahiruddin. I also welcome my co-convener, Dr. Shomishta Chandra. And now we are now for the first time, for the last few months we are facing a pandemic crisis due to COVID-19 infection. It is a global problem which has disrupted the social, economical, and environmental structure of the world population. People of different categories, doctors, scientists, and administrative officials of government and non-government are trying to find out a way how to combat with this pandemic crisis. Now, to get rid of this stressful condition, people are looking forward for some solution. They have lots of questions in their mind how to survive in this pandemic crisis. Few scientific, non-scientific, ethnobiological solutions are already suggested, but from several sources, but we are still away from getting the correct solution. We have three national and international speakers who will discuss the different aspects of physiological, socio-environmental, and molecular aspects of COVID-19 infection. I welcome to the speaker who are, in spite of their busy schedule, has given us few time to discuss with this pandemic problem. Now,
পেয়েছি
you will enjoy this seminar and you will be benefited.
হ্যাঁ, ওটা আমি
You
মোবাইল
are
থেকে
welcome
চেক
to
করছি।
ask few questions and our speakers will communicate
মোবাইল
with
থেকে
you.
তো এটা তো তোমার ইয়েটা।
Now, welcome to all participants and speakers
গুগল
once more.
মিটে
And now it is handed over to Dr. Shormishta Chandra, who will
হ্যাঁ,
introduce
লেআউটটা তো
our
স্পটলাইট
speaker.
করা আছে।
Thank you.
হ্যাঁ, স্পটলাইটই দেখাচ্ছে।
Thank you, Indranidhi. We are now continuing the session and we are encouraging all the participants to go through the session very carefully. Now we have Professor Sanjit there with us today. He's an eminent professor and scientist from India, and he will now deliver his valuable talk on the physiological basis of COVID-19. Being a junior of Biophysics and Molecular Biology Lab, I cordially invite you, Sanjita, our Sanjita, Professor Sanjit, to this webinar to deliver your values. Professor Day is a former professor of Physiology Department, University of Calcutta. Since 2012, he served and he joined CU in 2005. Before that, he had been in West Bengal Education Service. He did his bachelor's and master's from CU in Physiology and PhD from Biophysics Molecular Biology, CU. He did his postdoctoral research from UCLA School of Medicine, Los Angeles, USA in 2000 to 2002, from 2000 to 2002, and thereafter the Anderson Cancer Center, Houston, Texas, USA on 2008 under a DBT Overseas Fellowship. Currently, he is supervising research in his department for PhD students under his guidance, and till now, 9 students have been done their PhD and 5 are doing their PhD under his guidance. Research is the interested, he is an eminent scientist from Calcutta University and India, and he is interested in research on life care therapeutics. He is a member of various national and state level academic research bodies, National Academy of Science and Ausch Council in association with his regular university teaching. He is the author of more than 65 national and international publications of repute. With such activities, he is also in popularization of science in tribal communities and intellectually disabled children. He regularly for intellectually disabled children, and Professor Day also regularly participates in national news media through year. He is an advisor of NACI and thus regularly organizes program for school children. Now we are inviting Professor Day to deliver his valuable speech on the physiological basis of COVID-19 in this pandemic situation. Welcome, Professor Day. Professor Day, am I audible to you?
Yes, absolutely. Yes.
Professor Day, you can carry on.
Okay.
You can carry on the session.
Thank you, Shormishta, for for introducing me.
Professor Day, you can carry on the session.
Yes. Can you hear me? Can everybody hear me? Hello.
Yeah, carry on.
Okay.
Carry on, sir.
So okay. So everybody can you listen to me, right? All right. Okay. Thank you, Shormishta, for your introducing me.
Yes, you are audible. Yes. Sanjita, you are audible.
Okay, I'm going ahead. Okay, thank you, Shormishta. Okay, so it's really a great privilege for me that you have invited me and you have given me the opportunity to use this kind of international platform to present my views, my perspective on this corona crisis. Okay. I don't know how far I would like to deliver and enlighten you in that way, but I would, as a physiology teacher for last 22 years, 23 years time, I would like to share some of my thoughts. Actually, it's just I would like to share thoughts Okay, having said that, I must thank first of all the president of this meeting, Dr. Shebonti Bhattacharjee, and who is actually organizing head of this meeting. And also I would like to thank our beloved Indrani Chakraborty for his nice introduction and for giving me the opportunity. We had a very good time in our old days when I was in the West Bengal Education Service at Hooghly Mohsin College. And thereafter, I must say that Otanu was my student at that point of time, and I'm very glad to see him as now as my colleague. And also Shormishta was in that way. He was kind of junior to me and was a participant. We had just a very short, overlap in our PhD program. But we had a very, interesting to note that just by surprise, I came to know that Soumen, my favorite junior in my PhD tenure, is my co-colleague, co-speaker. So it was a very, we had a very, very fun time with him and all that time. And I would really, enjoy sharing the platform and to share, to know his views about this corona pandemic and all these things and what is right from the, what is happening there at the US. And okay, so I must also thank all the organizers and who are working in front of the screen as also in behind the screen. And obviously, I must congratulate Dr. Bholanath Pakhira and also Dr. Sharadindra Chakraborty, whom we had a very, had an opportunity to talk to them and for, organizing this seminar. And again, Shormishta, Otanu, so they are my, very close, beloved, junior. So I appreciate their effort, organizing these things. And it is really, I hope that they should continue it for their future endeavor because, in coming days, it is very likely that we have to depend on this, online system eventually. In coming days, at least for coming years, it looks like. Okay, so I mean, we have heard already. Now, again, I'm just going into the, the corona crisis. Okay, I won't say this is a crisis again, though it is almost 7 months have passed. So it is around on the eve of 2020. So on 31st December 2019, we came to know from some news media that this corona crisis is coming, and actually it has invaded China. And interestingly, after that, say just 7 months has crossed, right? So we are in the now in the month of August. So we have come kind of, almost millions of people have, affected. And although it is not to that extent, kind of invaded the earth. So but we never know, I mean, what is going to happen. Conflicting newses are there. Some of the conflicting, scientific reports are there. And while, preparing my talk to present before you, I was, kind of getting some kind of conflicting, some of them are very optimistic, some of them are not so optimistic. Again, the only thing is that to, save ourselves, to save our family, and to save our society. That should be the take-home message. A few days back, I just had a, I just presented in a similar way. It was kind of more popular way of, talk. So there I presented, I chose a topic of, traveling into a no corona land. Okay, so now, would there be a no corona land in near future? Yes, it depends on us only. Yes, absolutely. It depends on us means, that is, it is, just a second, I'm just preparing to present my screen. All right. So I hope that now you can see that the entire screen.
Yes, sir.
Okay, great. Okay, so before going into the crisis period, and also I would definitely I would give some very I would try to, but not I would give you some kind of panacea against this corona or corona COVID. But essentially, I would give would like to enlighten the some of the COVID aspects and the physiological response is essential. And okay, I'm representing my 150-year-old university, and I'm from the Department of Physiology, and it is almost century-old department of the University of Calcutta. It is kind of blessed with some eminent illuminaries like Nilratan Sarkar, like Rabindranath Tagore, like Professor Mohalana Bish, and also to some extent it was also at some point of time Acharya Popular Chandra Ray and also Jagadish Chandra Bose was also associated with our department. Okay. And so I'm very, very fortunate and that I'm sharing this platform and I'm representing, University of Calcutta. So having said that, I just very briefly go through the virus, the background of the virus. So essentially the why or should we actually, be afraid of the coronavirus? Actually, is it what it is? I mean, why it is so dreaded? Why it has, made this, space conquering nation to stand still for last 7 or 8 months. So that we need to understand. So this is just a, RNA virus with a plus strand. It is just absolutely a very simple, creature. That much I can say. Okay, it is not even living. It has got no living, symptoms or the characteristics. Even though it has made the human race into a standstill. Essentially, we need to go for, very briefly, I won't cover that much. I hope that my co-speakers will cover on that, but it is needless to say, but I need to go ahead with that. At that time, we had the common cold and the flu viruses. Like for the adults, have the 2 to 5 colds every year, 2 to 5 times at least. And when we were around, when we were below 10 years old, we had those kind of attacks. Some of them we got rid of them within 2 to 4 days time. Some of them actually were there to 10 days or so. Then the rhinoviruses, they are about the majority of the viruses that actually causes this kind of similar symptoms of the flu. Like so they are constitute around 30 to 50% of all colds. And there are about 3 species of them. And then is the influenza viruses. They are about 5 to 15% of all colds, and there are around 3 species which affect the humans. And they are about the diameter of about 120 nanometers. And then comes the coronaviruses. So they are around 10 to 15% of the all colds, and around 7 species are there, and that affect the humans, and they are about the 120 nanometers. And so there are other viruses also, adenoviruses, the para-influenza viruses, respiratory syncytial viruses, RSV viruses also known as, actually this is the abbreviation, and there are others. So actually this is the plus-strand RNA, and they get after entry into the host cells, they directly go into the the ribosomes can launch to synthesize the proteins of the viral proteins. That is the one part of advantage of it. So that is one of them. So now with respect to the coronaviruses and all that, with respect to the physiological aspects, what I'm going to discuss in front of you, it is just a kind of ready reckoner. So essentially it takes the lung and the oral route. So that's why I would so the lung infection, the GI tract infection, the liver, heart, kidney, and obviously the buzzword is the cytokine storm. So I just briefly cover that. And very interestingly, there are some clock infection biology. So that is very kind of emerging. Okay, and then I would briefly cover the why is coronavirus is now a household name and why it has gained such a high TRP. right? So TRP is a very common word now. The corona, I think it has, got gained the maximum, number of the TRPs, right? Okay. Now the physiological responses and the clinical correlates and the highlights. So we need to very quickly go through it. And this is the, some kind of simulation studies that people so far have got with the spike proteins and also the ACE2 proteins that actually, kind of receptor that is present, that is there in our, all the host cell epithelial or host cell organs, I would say. And the thing is that the SARS-CoV-2, and it is kind of simulation studies that have, with the nanosecond studies, they have, this is a simulation study, again, I'm saying that these ACE2 receptors, how they have interacted and at what time point they are maximally they are interacting. Okay, so this is again a simulation study. I want, so there are some though correlates with the real-time things. Now going into the physiological aspects, so this is the spike protein of the coronavirus. So that the spike proteins that stirred the exterior of the virus, have the receptor binding domains. So this is the receptor binding domains. This is also known as the S2 subunit, and this is the S1 subunit, and this is the receptor binding domain that actually finds and gets the receptor ligand specificity with the AC2, the angiotensin converting enzyme subtype 2 receptors on the human cells. Unfortunately, there are many of them across the across the organs of the human system, maybe in other mammalian system too. So this is kind of this animation will show will give you some enlightenment with regard to that spike proteins, and there are some AM proteins are also there. These ACE2, the one once they bind to that, so that is also not a danger. Even when there are some other proteases are also there in our in our organs. This is the furin that is some and the other enzymes also known as the TMPRSS2, another kind of proteases which on the exterior of the host cell are thought to break the spike protein at one or more cleavage sites. So making the domain receptor binding domain to cleave, and they kind of attach with this the epithelial cell or the host organs, making that exposes the fusion peptides. Then small chains of the amino acids that fuse the viral membrane with the membrane of the host cell. So this is very, very critical thing. Okay, so as you see, this is the fusion peptides. So with these tiny, machines, the virus can make entry into the, the receptor or the, the organ systems. That is the, the mechanism or whatever. The fusion allows the virus's RNA to enter the host cells where it gets translated into the proteins. So it releases the RNA. And then the foreign RNA hijacks the host cellular machinery to produce the RNA and the proteins that get assembled into the new virus particles. And it immediately kind of, it has the launching pad and everything is there. So immediately the RNA replication follows and making all these proteins for the virus, and making as the virus particle exit. So they kind of make another round of virus proteins and all the entire structure of the virus. So it is kind of they are kind of privileged. All the virus particles when they get entry into, if it is even into bacteria or it is in the other mammalian host cells or other organs, so they kind of survive in that way. So their survival instinct is very, very high. And unfortunately, so now the corona has got entry and they are surviving in us. So only way, that's why I'm saying that only way is to prevent the coronavirus is to maintain the social distance. Okay, so until and unless we get in touch with the corona affected or asymptomatic or any corona patients, so we won't, we had a very few chance of getting affected. Okay. Now this is, okay, so that previous slide was from a recent article of the Nature. So that they have, very nicely they have elaborated the, this kind of, interactions. So this was published in the 7th May volume of 551 of the Nature issue. And so it is just kind of very, they have illuminated it very nicely, even for the general audience. Now there is another, I'm just presenting this slide from the Physiological Review. So they have just, presented very nicely. I mean, what is the clinical correlates and the physiological responses? So this is very, very important again in terms of the, days of infection and all. So I think this would be a, enlightening point for everyone. Though not for the even for the caregivers and also for the administrators, I think this would be very highly valuable one, because even in these days in the early infection phase, like we have some kind of mild symptoms, like we may have fever, we may have cough or some kind of sore throat or some kind of dry, even the dry cough may not be there at this point, may have myalgia or some kind of fatigue, we are not feeling well or something like that, or mild headache. So this is the viral response with initial entry. And at this point, the upper respiratory, the nasal passage and the upper respiratory tract and all these things might get affected. And with our, household, techniques and all, we can get rid of the virus at this point. Because we can, if we get the, vapor and all this, kind of, what would I say, the, warm water, warm saline water, gargling and all these things. So we can get rid of the virus at this point too. This so viral response can be subsided at this during the initial days of the infections. Then the pulmonary next phase is the pulmonary phase. The respiratory failure happens at this point, and if it gets entry across the through our trachea and upper respiratory tract into the lung, so that would be that might be very fatal. Okay, until and unless we abate them in some way, okay, either clinically or physiologically. Okay, so even though many people have been affected with this coronavirus and they got rid of these things and they have been cured, and you see that now, in fact, if I am not wrong, around 65% people are getting cured in India, and the same ratio is there in our state also too. So nothing to worry about it. Even if you are affected, even if you are got infected, don't worry about it. You get you stay positive always, that you will get rid of your infection quickly, and you will not affect anybody in your home or in your society. So that is the pledge you have to make. Phase is though crucial for both for the clinicians as also for the individuals also. You may not have that much symptoms at that point, though there would be some kind of hypoxemia, some kind of tachypnea, even the shortness of breath, or even at that point of time, even if it is not cured and the viral load is really high, then there might be acute respiratory distress syndrome may come in. There might be some kind of shock, and also the multi-organ failure may happen. So sorry, this at that point the host inflammatory response happens, and that might spread to not only in the lung, throughout the lung obviously, and all throughout the alveolar passage, and also in the most of the lung system, respiratory system, and eventually that is its close neighbor organ, that is the heart, and it has also got the high density of the ACE2 protein, and also the kidney. Perhaps ACE2 protein, the receptor is highest in the kidney, in the proximal tubules. So that can make the clinician's life, or also for the victim's life, worse at that point, until and unless we get some kind of treatment by the chloroquine, hydroxychloroquine. Though it is not it is not a safe drug, it has it is an controversial issue, I mean, whether or not to administer hydroxychloroquine. But there are some clinical trials, even in Italy, even in China, so they have shown that chloroquine is working. And obviously, the people are giving the azithromycin, because this is the wonder drug for the upper respiratory tract syndrome. For most of the flu and the common colds, we usually get it, the azithromycin. The physicians, they prescribe it quite often. And obviously some of the antivirals, so that will give us certain relief even at this point. All right, and some of the immunoglobulins and the heparins. Well, why the heparins are required? So these are the some kind of antithrombin drugs. Okay, so these are thrombolytic drugs rather. And there are some other, some sort of, what should I say, that is steroids might be of some help. Okay, and also some kind of anti-IL-6 therapy and the corticosteroids and the camostat mesylate, and also the recombinant tissue plasminogen activator that would also help us. So, and this is the some kind of some of the drug designing thing. I just got some ideas that these are the protease inhibitor. This is known as the napamostat, and this is actually inhibiting the TMP RSS2, that protease that is acting as a protease inhibitor, which actually will not help to cleave the binding domain, receptor binding domain of the spike protein. So which would not enable to bind on the ACE2 receptor in that case. And eventually this infection phase will not arise. So at least there might be some kind of relief. Okay, but it is again all under strict clinical trial. And I'm not talking about the vaccines essentially because I'm not a vaccinology guy, or will not even the plasma therapies and all these things. But essentially, I would just briefly cover the physiological responses and why these things are happening, and why the multi-organ failures can happen. So I hope that though I have told you earlier, so this is the these are the organs that actually house the ACE2 receptors. This is the nasal passage, the goblet, basal, and the ciliated epithelial cells. They have abundant ACE2 receptors. As I mentioned earlier, this is very, very critical. The secretory, basal, and the multiciliated epithelial cells lining the alveoli. And the very similar structure is there, the same epithelial enterocytes. That's why we often we are getting that diarrhea upon getting infected. So even though our symptoms are not that much, respiratory symptoms are that much severe, but the patients are complaining of the diarrhea, or also they are also the anosmia, that is the loss of smell. Okay, and at the later stage, the heart and all these things, at least those who are having the cardiac patients, they are having this kind of troubles. And obviously, this is though there are people, the physicians are also complaining, don't touch your eye, and they are actually advising not to touch your eye. Why? Because this is also another route of entry of the virus. Because these corneal epithelial cells, they have also abundance of the ACE2 receptors, and the livers are also there. So liver cells also have the ACE2 receptors, and also have the bladder. Also, and quite obviously, I mentioned that proximal tubules have abundant, ACE2 receptor, and pancreas too, brain definitely. And most of the physicians, they are also saying that some kind of what I say, fog cognition. Fog cognition is that or the fog thought. That means some kind of dizziness, some kind of we cannot concentrate on something. Okay, some kind of some puzzling, even kind of dilemma or some confusion in a word. This might be the reason that the oligodendrocytes, even at the earlier phases, or we may not know what is the viral load, and we may not know that whether it has gone into the lung, and it is the viral load is severe, but even though there might not be any symptom. So those are some puzzling clinical finding, even in our patients, even the patients of our West Bengal. All right, and also the reproductive system also, they have their the ACE2 receptors, and they are quite understandably these organs might be affected. All right, so and since that I must say something more on that, the cascade of the injury of the lung, I must concentrate, because this is the most talked about route of entry, and also the mechanism of infection. And what is the cascade of injury? The new hypothesis suggests that SARS-CoV-2 attacks the endothelial cells which line the blood vessels surrounding. That is the job, right? Alveoli actually should be lined by the capillaries. So capillaries actually, they work hand in hand, and they have some kind of tight junctions. They have their cell membranes. They work hand in hand with the alveoli, because of the fact that some of the cells essentially they are only to facilitate the the gaseous exchange, oxygen and the carbon dioxide, and nonetheless there are some other cells and some other molecules, they also communicate, some of the cytokines and all. Even though some small infections, some minor infections, they get also affected. You see, this is the alveolar epithelial lining, and these endothelial cells cause the fluid to leak into the vessels, trigger the blood clotting, and summon a host of the immune cells and the messenger molecule that cause the widespread inflammation and make this thing much worse. Okay, and that is kind of this, we can explain the kind of cytokine storm, because some of the macrophage-like cells, those are present in our blood like lymphocytes. So they find, okay, something is gone, something is wrong, and there might be some kind of attack, and what they do, they actually present some of the fibrin clot, some D-dimers and some platelet come into the play with this chemotactic event, and they block the alveolar the blood vessels, making the kind of blood clotting in the blood cells. So that actually is very, very dangerous. That's why I mentioned that why the heparin and other plasminogen activators are given, because just to get rid of these clots. Because after that, if the oxygen and the carbon dioxide cannot pass through, they cannot be carried away very nicely. I mean, that is the last word for the alveolar cells. That is their job. And even that, after this, all this kind of chemokine entry and the cytokine storm, what we call it, the alveoli is filled with air. Watery liquid. The fluids, and making the thing, worse for the alveolar. And the why? Because that the surface area is reduced for passage for the oxygen and the carbon dioxide diffusion. And so that is the danger of the shortness of breath, and also the huge pain and huge respiratory distress out of this the lung infection. So okay, so so this is the thing. And so there are a couple of other theories. They have, the airways epithelium, these, so actually this, this is the mechanism, this was the, people have worked out already the respiratory syncytial viruses. They have worked out, and they, upon entry, they, capture the, a whole bunch of the, genomic phenomena, and also the, they also, trigger this, the proteomic thing. They, changes the proteomic profile in that cell, and eventually the cell stress responses, and eventually that makes the cell to death. Okay, and they actually, the adaptive immunity and the innate immunity work hand in hand to, make the cell, okay, to go into dump. Okay. And this is the schematic representation. I borrowed the slide from the physiological review. So this is a very wonderful review that people have just presented. This is a schematic representation of the SARS-CoV-2 cycle in the aeroepithelial cells, and also the inflammatory consequences of the viral infection. And essentially, this is some of the therapeutic regime are also been highlighted over here. So some of the remdesivir, how the remdesivir work, and the some lopinavir work, and the ritonavir work, and the against this antiviral as an antiviral drug. And because they actually prevent, because some of them they mimic the the viral RNA in the ribosome, so that they are not being translated into the viral proteins, and eventually this viral load would be reduced. So that is the mechanism of action so far, and people are working really hard for it. Okay, and they are actually getting some success. I would say not all the partial success. I would say. Again, as I mentioned here, this is very, very important slide. That is the receptor for the coronaviruses and their abundance. And now I'm going back to some other physiological responses are also very come into play, and this is the anosmia. Anosmia is the loss of smell. People also feel about it, and actually this is not much known about it. Okay, so essentially what I would say, this is the some of the cells, as you can see here. Perhaps you can see, right? So as I go through the slides here, point out. So is it? I hope there might be some lag in the slide. Okay. So, however, as you see that human upper respiratory cavity on the left, so this is here showing the interface between the olfactory sensory epithelial, that is the OSE. Okay, this is the OSE, olfactory epithelial, the circle cut out. So that has been projected, zoomed out here. Here, this is the stem cell and some of the accessory cells, and some of the the olfactory bulb cells in the brain. So they are very close by, right? So, and this slide actually, this drawing actually this depicts that the olfactory nerve carries the signals from the OSE to the olfactory bulb. All right, and this turbinate bone. So this is the turbinate bone in the nasal cavity, serve to distribute the air along the nasal passageways. In here, there are several types of cells. In addition to the olfactory sensory neurons, all right, and whose processes they actually make up the olfactory nerve. These sustentacular cells, that is the cells, okay, these likely allow the greatest entry of the SARS-CoV-2, but the microvillar MB cells here, so they also take part also, all right, and the stem cells also appear to have the appropriate receptors to permit entry of the virus. So as do the Bowman's gland, BG here, all right. So here, as you can see, the Bowman's gland. So there are a couple of, this is a very unique structure. This is the modified neuronal cells, we say. This is, there are, conglomeration of the receptor and also the, modified cells here. So very unique situation here. And the damage to any of these cells could affect the proper functioning of the vessels, and will not feel the smell, all right? And many of them, for your information, have very, not so well, but very rich abundance of the ACE2 receptors, but they have their ACE2 receptors. So that's why upon entry, and this is the closest thing, right? That's why people are saying us, people are instructing us all throughout that people wear mask, wear mask, wear mask. Okay, so this is the major route of entry. So you please don't ignore these instructions, and also don't ignore the COVID. Okay, don't ignore the coronavirus at all. Okay, now having said that, now I am quickly going into why the gut health and the diarrhea and all these things. So as I mentioned, I very quickly almost the similar situation that I presented over there in the for the lung, that they have their ACE2 receptors, and they kind of they have their entry. They actually share the same epithelial structure. That is the most interesting point. So some of the reviews, they have very nicely represented this. This is the respiratory tract. This is the epithelial cells of the lung, and this is the intestinal tract. So this is the respiratory tract. This is the intestinal tract, and you see, the similarity of their structure, and quite obviously they have their, they have their ACE2 receptors even, and they have the similar kind of the lymphocyte migration, and obviously the bacterial seeding and through the reflux or the aspiration, and they have their some kind of the dendritic cells. As you see, the dendritic cells, they have their projections. They can make entry into everywhere because of their macrophage-like actions. Okay, phagocytic actions. They can travel anywhere. All right. So what are the influencing factors? Obviously the diet. Okay, so your diet is very, very important. Your ingested or the aspirated bacteria. If you don't smoke, so you are very much protected. And if you are free from pollution, so if you are using mask, okay, so your chances of getting infected is much less. And obviously the prebiotics and the probiotics. Very interesting studies have come up. Even I'm not presenting though, the people have found the lung gut axis. I was very surprised to study all these things a few years back, that how the lung is having the connections with the gut. And that too, not even the gut, even it is the bacteria. You might be surprised that our, the commensal bacteria, they actually help us in so much way. Even they take care of our lung, they take care of our pancreas, they take care of our liver and whatnot, and they take care of our brain. You answer the gut brain axis was quite common, but I was quite surprised to learn that there might be gut lung axis too. Okay, so this is very, very interesting studies, and I think all the those who are from the field of physiology and from the clinics and also from other fields also, even from the those who are attending from the who are not from the field of science, I would encourage them to keep at least have some knowledge about it. I mean, why our prebiotic, that is our curd and the yogurt, are very, very important. Why we should quit smoking, why we should get rid of, we should make ourselves, keep ourselves healthy and hygienic. Okay, and why our diet should not be very rich with some unnecessary, fats and oils. So yes, fats and oils are very, very required. So some of the fatty acids and are very, very required, and those are really friend for us, not only friend for us, as also for the even for the bacteria also. I mean, those are the healthy gut bacteria. So that is very, very important. These some of the fatty acids are also very important. Okay, and reduce the administration of antibiotics. Antibiotics also the reflux. What should I say? That is that is the pantoprazole and all these anti-reflux agents. So those are not at all the friendly gut bacteria friendly elements. Okay, because to maintain your health, so why people are now which people are more getting affected? Okay, so they must have some kind of history. Okay, so they must have ignored or have some kind of they have made trouble to some of their systems. Okay, so and I would just very briefly, I think Professor Dr. Soumen, Professor Paul, and also my next speaker will also enlighten with that. And some of the administrators, some of the frontline workers, even the doctors, caregivers, and even the policemen, why they are getting affected? Because of their disruption of some of their physiological systems. Okay, and including their sleep. Okay, so I'm very quickly skipping all these things. As I mentioned, I hope I have mentioned all these things in my previous slide also. And that's why if we have disrupted our circadian rhythm, that circadian means around a day. Okay, that means this is our kind of biorhythms. So this is very, very important, as we need to maintain our sleep cycle, we need to maintain our food cycle, and even if we disturb the food and all these sleep cycles, that is not a good message for us, for our physiological system. And quite interestingly, we got that another word, that is the circadian and the infection axis. So that is the very new word, and we got it from our from one I find two Indians. They are working there at US, and they have presented this thing in the one journal, one article in the Nature Review of Molecular and Cell Biology, and previously they have published in Science. And they have identified that the COVID-19 management in light of circadian clock. So that is very interesting name they have given of the article title. And also, having said that, I'm not going into that circadian axis though at this point, because due to the paucity of time, but at least I can say that we cannot disturb our circadian axis. Why? very, very important to maintain our immune system. Coronavirus attack those individuals, those who have compromised immune system. And who have compromised the immune system? Those who have disrupted their circadian axis. At least you know that I cannot say, because I have my best wishes, I have my best regard for the frontline workers, like the medical practitioners, those who are at the front, helping the patients at the bedside, caregivers, and also the police persons, and most of the other caregivers also, and in the administration side. All right. So, but they need to take care of themselves first. Okay. They need to be very happy. They need to be at least de-stressed. Okay, because what I believe from the physiological point of view is that stress actually is the main killer. So you need to be happy. Okay, just to maintain this, hypothalamus pituitary thyroid axis, or hypothalamus pituitary or the adrenal axis. So I believe that the hormones are actually your caregiver, the main caregiver of your body. So that is my message, that please remain positive. That's why my previous presentation was to keep yourself, happy, and have some kind of vitamin H and vitamin P. So vitamin H and vitamin P are nothing but I would say, so these are the happiness vitamin, and the positive, and the vitamin P is a positive vitamin. And also do some, and for the students and for the youngsters and for everybody, quite obviously, get some vitamin C, that is creativity. You engage yourself in home, and also diligence for innovative work. At least all type of who are from the field of arts, from science, do some innovative work, and engage yourself in exercise and yoga. And for your information, my next but other speaker, Soumen, he's a wonderful, he's a excellent exercise man. He was my super, he was my super junior colleague, and he always fought with me in my arm wrestling, but he never won with me. And anyway, but he was he did gym and everybody, and he ran, I think the New York Marathon also. Okay, if I'm not wrong. Okay, but he's a very, very wonderful chap. All right, and so so there are many yoga and all these things, meditation, the mindful meditation. The people are very are nowadays saying that these are some of them are doing some clinical trials. Okay, I'm not going through that, but I would say, okay, de-stress yourself, keep some time for yourself, at least for 10 to 15 minutes. Okay, calm and quiet manner, whenever you get time. Even you are a working mother, even if you are a very busy father, even you are a policeman at work, even though you are a physician at the bedside, okay, please do make some time for yourself, and make some time for de-stress yourself. Okay, so that is very, very important. Okay. And so that's why I just give you some positive stories. I would like to end with some positive stories. So Vietnam, in July 9th, they mentioned, the media, actually they were claiming from much earlier that we had no death. Vietnam was the country actually immediately south of the China, the epicenter of the coronavirus pandemic. But even though it had no death, okay, quite interestingly. And what was their success story? So they had their, many, system. People have followed. The, first, award should go to the people of Vietnam. Even though that country, the administrator and all, they did not made, such kind of harsh treatment or something, but people followed it, whatever they made. Okay, so they, they stopped their flight to China and everything. They made their, lockdown, but the people followed whatever the instructions and some of their administrative measures. All right. So some of their, other countries like Singapore, New Zealand, South Korea, they have also very good stories in front of us. So always remain hopeful that even though some scientists are saying that, okay, it will come and it will be come with much dreadful, pandemic later on, but don't worry for it. Remain positive, remain healthy, maintain the hygienic practice for next couple of months, even couple of years. Okay, so you won't spread the coronavirus anymore. That I can say. Even so, this is the epicenter of the the Hiroshima, where the atomic bomb where they have bombed the Hiroshima city very nearby. So this was their prefectural the industrial promotional hall, and the only building that actually survived. And now they have made us a memorial center there. So but the Japanese people, they never they never complained to the Americans. They just built up. Okay, even after this kind of, so you just imagine such kind of damage what happened. But people survived. People are doing very nice work. They all kinds of, they have won Nobel Prize. They have made they've got so many accolades in so many fields. So we have nothing to lose. We just would like to have our best and positive ways. So now it is time to acknowledge. Obviously, I would like to acknowledge my university administrators for giving me all these kind of academic and administrative support throughout my teaching career, and also all my teachers. First of all, I must acknowledge my teachers for whom I am presenting before you. Okay, with their I'm just percolating their knowledge. That's all. And okay, to the principal of the SNCG of your college, and the head of the Department of Physiology of your college, and all the faculties, and my beloved students, and all the participants. Okay, and last not the least, my family. So they have contributed to me immensely. Thank you very much for your patient hearing, because you have to be patient, because you cannot make any noise. Okay, thank you very much again. Okay, so I have finished. Is it the question answer session will happen now?
Yes,
or,
sir. Sir, just visit the chat section. You can see lots of questions there.
I answer now.
Yes, sir.
Okay. So, or you can, what you can do, I cannot say see that chat section. Okay.
Okay, I will deliver the questions.
Sure, please.
Questions. What a fabulous talk, Professor Day.
Okay,
We are actually overwhelmed with your talk, and as a junior, I am really proud of you, Sanjit. Very, very enchanting and charismatic talk. Now we have some questions. Banerjee and Dr. Bipin Kumar Marji, they are actually asking the same question. Can we block the infection of COVID-19 by blocking the ACE2 receptor or by shut down the gene for ACE2 receptor?
Okay, this is an interesting issue. First of all, if we shut down the ACE2 receptor, that would have very dreaded effect. So we have to take the other way around. So we have to get some kind of as I mentioned, have shown their way some of my previous slides, that we have to take some of the protease inhibitor instead. Okay, because ACE2 receptors are very, very important. So that will have physiological consequence. So better to inhibit some of the some of the protease inhibitor instead. All right, and though there are some reports that some of the small molecules they are actually working on that. So they mentioned that yes, ACE2 receptor, in where those receptors are very much abundant, they can be of some use. Okay, so people are actually started using, but I'm not so sure about it. So whether they have used it in a clinical trial basis. Okay, but this is all in the animal study. Maximally, that much I can say. Okay. Anyway, that was a very good strategy though. Any further question?
One more question. He's from Behela College, Waliza Ansa. He's asking that whether HCQ is effective in all 3 phases of COVID-19, or it is more effective in hyperinflammation phase.
Right. Actually, again, this is very tricky. I cannot say very, I cannot address the question very easily, as if it is not mentioned if it is not supported by the clinicians. Okay. Essentially, I would say initially not in the hyperinflammation phase. I think the hydroxychloroquine will not be of any use. But in the initial phase, hydroxychloroquine and the azithromycin, that is the azithromycin, this regime is far more effective. So I don't think that would be effective anymore in the later or the phase 3 of the inflammation. Okay.
Okay, Professor. There one more question here from Bornali Raiboshu, Bornali D.
Okay.
She is asking about what is the prevalence of association of specific blood group with COVID. Is there any SNP study?
So that is we have gone through it, but again, I would not comment on it because there are a few studies. They are saying that there are some blood groups they are kind of very much in they are actually in beneficial thing. Their blood group are beneficial because they won't be affected by the coronavirus. But again, I don't believe at this point. I cannot say anything. I cannot say I don't believe, but it is a kind of many conflicting papers I have also found. So that's why I would refrain from commenting on that.
What a fabulous talk again, Professor Dept. And please be with us, be in the line. We are expecting you for further sessions.
No problem.
Okay.
Yeah. So I am muting if there is no other question, or if there are
if you don't mind, I have one question.
Okay, please. No.
Why RNA dependent RNA polymerase inhibitors are not given rigorously?
Well, actually, that one. Actually, I was just listening 2 talks yesterday. One by the Dipoman Ganguly. He's a scientist, physician scientist from IICB, and also some Pradeep Nayar. So he was mentioning there actually some of them. So Dipoman was kind of addressing some of the questions. So someone asked that. Again, I think it might interfere with our host systems. So it is not a safe point to use the RDRP. All right, do you follow what I'm saying? So kind of it might have some kind of widespread effect. So better to since the remdesivir and the other antiviral drugs, they have some kind of specificity. So still now, I would say that these are the safer drugs. But again, some of the RDRP inhibitors, they are also being in trial. So they are also trying for it. Some of the labs are also working in it, because these are specific targeted therapy that people can think of. Those are one of the basic strategies people can think of. Very nice question though.
Thank you very much, Sanjit. We are switch on to the next session.
Please.
Switching on. And now we have with us Mr. Tapas Bhattacharjee. Am I audible to Mr. Tapas Bhattacharjee?
Yes.
Mr. Tapas Bhattacharjee?
Yeah. Am I audible?
Yes, you are audible. Yes, you are audible.
Shall I start or?
No, I have to give a short introduction for you. And Mr. Tapas Bhattacharjee, welcome you in our session. And Mr. Bhattacharjee is a WBCS officer from cadre 2008 and initially posted as BDO in Narayangram of Jhargram subdivision of West Bengal, Midnapur district from 2011 to 2015. He served as Deputy Magistrate and Deputy Collector in Diamond Harbour subdivision of 24 Parganas from 2015 to 2018. And thereafter, from 2018 and 2019, he served as a Magistrate, Deputy Magistrate and Deputy Collector in Howrah and successfully carried out the changes of district, charges of this district as Nodal Officer of Election as well as Nodal Officer of Health. Thereafter, from 2019, as the Deputy Commissioner of Howrah Municipal Corporation, he successfully managing the present pandemic situation of the district from administrative viewpoint. Mr. Bhattacharjee also have immense experience of working in Kolkata Police for a long period of more than 5 years. Now he is working in police commissionerate also as a police commissioner. Am I wrong? Police commissioner or deputy commissioner? Deputy commissioner of Howrah district and deputy commissioner. Okay. Now we are welcoming Mr. Tapas Bhattacharjee to deliver his speech, and he will deliver the speech from administrative point of view in this pandemic situation. Welcome, Mr. Bhattacharjee. You can carry on.
Thank you very much. Thank you for giving such an introduction of myself. Actually, I'm working as Deputy Commissioner in Howrah Municipal Corporation right now, and I feel privileged to be part of this webinar and given an opportunity to speak on the emerging pandemic crisis, the COVID-19 that we are right now experiencing on a global scale. And I've been invited to speak on my subject matter, which is the crisis of pandemic, the social and environmental perspective, all from the administrative point of view. I thank the organizers, the Department of Physiology, of SNGG and DCG to give me this opportunity and to this platform to present my subject matter.
So kindly, can you adjust your camera? Kindly, can you adjust your camera, Mr. Bhattacharjee? Yes. The picture is not coming clear.
Is it all right? Is it all right now?
Slight. You must tilt it slightly.
Actually, it's on mobile phone, so obviously it's experiencing some video problem as well as the panning issue is there. So
half of face is showing.
We are just showing you half of your face. Just place the camera little bit behind, little bit distant. Now it is quite okay. No. Okay.
Okay. Am I visible now? Yeah. At the very outset, I want to emphasize the fact that following COVID-19 pandemic, the administration not only in India but also anywhere in the world has seen this kind of crisis before. My previous speaker has elaborately spoken about and given us the insight on how this COVID-19 actually causes or wreaks havoc inside the bodily system and what else we need to do to take care of ourselves. I will just present a brief presentation on a brief speech, because I was in a VC and it's overlapping with this one also. So I'll be keeping it as brief as possible. So as I was speaking, that at the very outset, I want to emphasize the fact that following this COVID-19 pandemic, the administration anywhere in the world has seen this kind of crisis before. I hope you all will agree with this. And why me? Even my previous generation did not witness this kind of epidemic of this gigantic proportion. To be very frank, no administration or you can say any healthcare system in India saw this coming and hence was hardly prepared to tackle it. COVID-19 has thrown the biggest challenge to human existence that the modern day world has ever seen before. And naturally, the administrative response to any crisis is shaped by the extent or severity of the crisis, and as also through the experience that is being gathered over the years to tide over such crisis, there is a laid down standard operation procedure for any kind of calamity, be it flood, earthquake or cyclonic storm, which the administration has successfully tackled over the years. But this COVID was something different. This COVID has thrown an altogether different and unique challenge to the officialdom, to the administration. And what do you do with the situation where the evacuee in any calamity situation is himself a life threat to the rescuer? I repeat, what do you do with the situation where the evacuee is himself a life threat to the rescuer? We have recently seen that when we had the severe cyclonic storm Amphan. You all must have had very raw memories of Amphan. Large parts of Sundarban Delta, South 24 Pargana, Howrah, North 24 Pargana has been very, very badly affected. What do you do when the very healthcare system on whom the life depends refuses you to give admission in any healthcare system or give you medical care? What do you do when a doctor don't treat you? Clinics are shut, clinicians, they move away from you, medicines are not available, or no certificates, even the death certificates. I repeat, even the death certificates can't be given to any patient who died a suspected COVID death. What do you do in that situation? The administration has not seen this ever before. Even the dead body handler or the undertaker refuses to cremate or bury a dead body. Did we hear this before? We never. But this happened during this COVID pandemic. So obviously, this pandemic is not a normal, this calamity was something which the administration wasn't fully prepared of or saw it coming. This is certainly not the society we know or live in, do we? No administrative power can compel a society to discharge the moral obligations that we have seen while growing up. This is simply chaotic. Now, the administrative impact, since I am giving you an administrative overview or a review of this COVID pandemic, I have divided this administrative impact or this review into several parts. I'll be touching upon not all of them, but the primary ones which have affected our daily lives as a commoner. The first of all is the PDS, which is the public distribution system. Healthcare system is the second. Third one is the imbalance in the demand-supply equation. That in administration was more visible because they had to tackle the demands of the people who were calling in, the people who were pouring into the collectorates, in the subdivisions, in the block headquarters, to the BDOs, in the Gram Panchayats, for their daily need, for the daily help. So that was something which administration has not seen before in such scale. And obviously there were issues like hoarding. Any kind of calamity, obviously throws opportunity for some crooked people, some unscrupulous people who actually indulge in hoarding, and thus leads to an artificial increase in the prices. We all know that. Then again, there was the issues of migrant workers. We all know the migrant workers, they came in hordes, and then there was a risk of infection, which actually led to a great spike in the rural areas. Obviously, the policing pattern has also undergone a sea change during this COVID-induced, or I would say a COVID-affected policing. And above all, this has led to a socio-economic imbalance. Common man has undergone a sea change because this entire thing has led to the more dependence on the administrative machinery, which was reeling under a shortage of manpower, and also dealing with the pressure of delivery mechanism. So just to deal with a few of the important topics and to touch upon those which I thought should be deliberated upon, and to start with, I would just stress upon the PDS system. Naturally, with such prolonged lockdown in rural area, there was immense pressure on the PDS. The markets and the retail groceries being shut, that has put huge pressure on people, especially in rural areas, to fall back on PDS of the government. Mostly in those PDS, social distancing norms and other society parameters went for a toss. We all have seen the visuals in different TV channels, media channels, how the social distancing norms has gone for a toss. We have hardly seen people wearing masks, and we are hardly seeing people carrying sanitizers or taking the basic precautions. This is obviously there are examples where social distancing norms were definitely met. I'm not generalizing the issue, but this we have witnessed in the last 2 or 3 months. You all will agree, I hope. Administration all over India had real hard time in putting these things in order. Now, this has led to an adverse pressure on the healthcare system. You can ask how. The healthcare system actually, again, depends upon the demand-supply equation. Did we ever imagine what will happen even if 1% of the overall population of India becomes COVID affected? That is roughly around 1 crore and 30 lakhs. We are already reeling under so much of pressure when hardly 17 or 18 odd lakh people are affected. I'm talking about 1 crore more than what is now. This is beyond imagination. This will not only leave US, the United States, a distant second, but also will break our healthcare system. We are already hearing patients not being able to fetch a bed, not even had to wait for hours. They even had to wait for hours for ambulance services to get their near and dear ones admitted, or even for cremation and burial, they had to run from pillar to post. So this has led to an imbalance in the healthcare system in that sphere as well. The healthcare system never faced this kind of disaster before. Government of India and also the ICMR is therefore compelled to come out with concepts like home isolation or safe home concept. This is and they are concentrating on the ones who are actually in dire need of help and leaving the others vulnerable to take care of themselves, to fend for themselves. This was something unheard of in the medical fraternity, and I hope you all will agree as well. Actually, I work in a government organization. You all know, as the moderator gave an introduction, I work in the civil service as a civil servant, and working as a deputy commissioner in Howrah Municipal Corporation, which is at the forefront of the COVID fight against this pandemic. So we from this organization, we have floated an ad a couple of months back, which was basically an appeal to the doctors, to the Indian medical associations and other NGOs who are otherwise free during this lockdown to come forward, and the appeal was to come forward and offer their medical services against this COVID fight, so that we in corporation can actually provide better services to the people under our jurisdiction. And this was not at all a free service. We were offering handsome remuneration to any doctor or any medical practitioner who decided to come forward and help us. Unfortunately, unfortunately, none came forward. Obviously, fearing infection, none came forward. This is, I suppose, is a general picture across the length and breadth of our country. I personally feel a part of a society died during COVID, because what I have experienced, I just cannot share on this platform. This is something too gory to be shared, too painful to be shared. So I just quoted a simple example where we floated an ad. We actually asked doctors to volunteer their services, obviously against a hefty or suitable remuneration, but unfortunately none of the doctors came forward. I'm not talking about the government doctors. I'm talking about the clinicians, the physicians, the doctors who shut their chambers and they decided to keep themselves inside, keep themselves indoors. We have actually prayed, we have actually left the message to those residing inside Howrah to come forward and share the services, but it did not happen. This is just one aspect of COVID. One more grievance I would say, which many administrators like me must have had experience of. A glaring example. One person, a middle-aged person, and a lonely fellow. He was unmarried. If I don't exactly remember his name. He came back to his para, the mohalla. He came back to his mohalla after being cured of COVID-19. But unfortunately, he wasn't allowed to enter his own home. It's a rural block in Howrah district only. It's within this district only, Howrah. And mind you, he was carrying a COVID negative certificate. He was carrying a COVID negative certificate. Not a soft copy, but a hard copy he was carrying. And despite that, he was not allowed to enter in his own home by the people, by the villages. And he was chased away by villages and had to sleep, had to spend his 2 sleepless nights on the railway platform, empty railway platform, which again subjected him to drug abusers or the bootleggers. Finally, the higher echelons of the administration had to intervene, and the person was sent back home with the help of a magistrate. So this is another aspect of the COVID that the society has experienced. Even the own people has turned their back on the person whom they used to talk the very other day, who were supposed to be their own relatives, who were supposed to be their well-wishers, and they have to all turn their back to the person who is carrying a COVID negative certificate. More shocking, you must have all heard few days back. More shocking was an incident when a block development officer, a BDO who is the face of the administration during this ongoing pandemic, wasn't allowed to enter a rented accommodation by the landlord, who herself is a government servant. Can it be more pathetic than this? Where as a society we are heading? Where will this end? And what this will lead to? Actually, this COVID pandemic has bared all of us. All of us. We, the so-called civilized people, are left bared, absolutely naked all over. Further, I would also like to stress upon the healthcare system, the adverse impact of the COVID on this healthcare system. This particular COVID pandemic has given a death blow to the National Health Mission programs. It has put a severe strain on that. The maternal and the child care programs, the vaccination schedule, the prenatal and the antenatal checkups were badly affected, with hardly any ASHA or Anganwadi worker being mobilized during lockdowns, and still administration is having hard time in mobilizing them at the field levels. How could you? We cannot. We just cannot, because safety comes first. We have to provide all safety gears, and despite providing all, we cannot ensure that each and every Anganwadi worker or the ASHA had actually visited, house to house visited, and actually taken note of the antenatal or the prenatal checkups, the scheduled checkups. And even if they have visited, we cannot guarantee that they were being welcomed by the people in general, because there were hundreds of such instances where the Anganwadi worker, where the healthcare workers, where the frontline workers at the very frontline level were being shooed away, chased away, abused. We have been getting this kind of reports day in and day out. So in administration, we are having a hard time in actually perpetuating this national health program. Now, obviously, this COVID pandemic, I'm just moving on to another impact of this COVID on the rural sectors, on the rural economy. As we all know, the rural economy has been very, very badly affected, just like the urban economy. The risk of the spread in rural economy is heightened, the rural areas rather is heightened due to many things, many prevailing things like the lack of awareness, limited supply of clean drinking water, low levels of nutrition, and most importantly, ill-equipped and insufficient public health centers. I being in the administration, I have no shame in accepting that we still lack eons. We have to actually boost up our healthcare infrastructures at the very basic, the primary healthcare level, the urban primary health center level. We have a lot of tasks cut out. We have to actually do a lot of work in the healthcare system. Everyone present here would actually agree with this. And the rural sector, after being hit by these migrant workers, which led to the spike in this COVID-19 infection, were reeling under this kind of problems. And that led to the patient migration from the rural to the urban centers, which again, the urban healthcare system was again under tremendous strain to cope up with this increased patient pressure. The informal industry in cities were being badly affected. This has resulted in the loss of rural income. And what's more, the massive layoffs, which actually we will not be able to get the clear picture. Maybe 2 months or 3 months down the line, we will be able to get a picture of this layoff. But still, what we gather as of now, there has been a massive layoff already in different industrial sectors, in different areas, different domains of production, which actually sustains the livelihood of the people, has undergone a massive layoff. This massive layoff and the lack of relief measures are pushing migrants to return to the villages, and which has already led to a spike in infection I already talked about. Activities like farming, poultry production, goatery, apiary has fallen sharply. Vegetables rotted on the stranded highways has led to shooting prices. The rural hearts, we all know there is a weekly rural hearts. We must have seen or heard about the rural hearts. These rural hearts are a lifeline of every rural area in Bengal, in other states like Jharkhand, Odisha, Chhattisgarh, and this COVID-19 has broken the very back of this rural hearts, the rural people who actually thrive on this. Another aspect of this COVID-19 pandemic, which has led up pressure on the administration, is increase in domestic violence. We all know that this is needless to say that lockdowns has led to a spike in domestic violence. The statistics from National Crime Record Bureau as well as the State Crime Record Bureau, they already suggest an increase in 20 to 25% of cases vis-a-vis last year. And to make the matters worse, the closure of courts, the lower courts rather, the high courts obviously were closed, and now they have started functioning, but then that is also a handicap for the rural people who do not know how to use these virtual platforms to get their grievance redressed. But still, 20 to 25% case spikes has been recorded by the NCRB as well as the SCRB. And to make matters worse, the closure of courts, the important offices of grievance redressal has led to more sufferings of the victim. And that victim were inevitably women. Though of late, the courts, and obviously I talked about this, the Human Rights Commission and the Women Commission, they're operating through virtual platform. But can you tell me how many women in India, in the rural India, in the remote India, know this route of redemption? How many? Practically a minuscule percentage, not even worth mentioning on this platform. I move on to another aspect of this COVID pandemic is COVID-induced or oriented policing. We all know the administration, the civil administration and the police administration play a pivotal role in actually holding the very fabric of the society. The very administration and the policing, they actually run the day-to-day administration. They actually are one of the pillars. Obviously, the judiciary is another pillar. But when these two pillars fail, obviously people then move on to the judiciary. But if these two pillars do not function at all, or if these two pillars function in a unidimensional way, which is the COVID-induced functioning, I would say a COVID-induced or oriented policing approach, because the police is being forced to conduct its day-to-day policing based on COVID-19 led or induced ways. The policing, the most part of the days, the major part of the day is gone in enforcing either containment zones, enforcing lockdowns, ensuring the migrant workers reach their homes safely, and doing nakas or district border. Apart from that, they hardly have any time to deal with the traditional policing. The case diaries are accumulating, the inmates in jail are rotting for want of bail, and the common man continues to suffer. The primary cogs in the wheel, I would say these are the cogs in the wheel of the society, the civil administration and the police administration, and obviously the judiciary is there. And if these three entire pillars, they fail, the society will crumble. COVID is just ensuring the society crumbles to its own feet. And actually doing what? It is actually shutting the door of redressal for the commoner. So obviously, this COVID-induced oriented approach, the COVID-induced policing, as well as the COVID-induced approach that the administration is forced to take, and the policing is forced to take, is leaving the traditional administration as well as the traditional way the police actually performs its duty, is leaving and shutting the door, actually leaving a commoner with no other way to address his or her grievance. This is something which was unheard of before COVID-19. And obviously this is also leading to increase in lot of cyber crimes. You all know, because there are so much of, we have heard few days back of the virtual platform through which so many meetings are being arranged is used for a very unscrupulous purpose through the dark web. We have all heard about the dark web. We actually do not take any precautions. We are again adhering to the same platform because we are hardly left with any other option. And when people are locked down, forced to stay indoors for so long, the digital way of leading life is obviously becoming the order of the day. The digital transaction is taking place. People are talking over through Google Meet and other virtual platforms like the way we are doing now. And this can make vulnerable so many things. This can make us vulnerable to so many cyber-related frauds. And this is happening. The cyber-related cells are brimming with so many complaints, and which they fail to address, because obviously again the COVID-induced policing as a COVID-induced oriented approach is coming into their way. With these words, I would like to actually wind up. As I told you before, I would be presenting a very brief presentation, a very brief speech on this administrative approach. I hope there is a feedback session, so if anybody is interested in asking questions, he or she is free to ask. Thank you.
Thank you, Mr. Bhattacharjee, for your valuable and informative talk. Am I audible to all?
Yeah, you are audible to me.
Thank
I can
you.
hear you fine.
Okay, that's fine. Thank you, Mr. Bhattacharjee, for your valuable and informative talk. We're actually going through severe dilemma in this period, that what to do and what not to do. And your talk gives us that and is addressing about this addressing. Now we are entering into the questionnaire session. There is one question I can see. Any question?
Everybody is saying thank you.
Any question here? Okay. Okay, stay with us, Mr. Bhattacharjee. We are entering into the next session.
Okay, before you enter, sorry for interrupting you, ma'am. Before you enter, and if there is no question, I would like to thank the organizer of this webinar, basically the organizing committee, the Honorable Chairperson, Dr. Sevanti Bhattacharjee, SNGG, DCG. I would also like to extend my thanks to respected advisors, conveners, Honorable Technical Assistant, and my special thanks to the Organizing Secretary, Dr. Atanu Saha, who is a member IQAC and is a good friend of mine, to actually give me this opportunity on this platform to speak on this administrative review and this issue of ongoing pandemic. Thank you very much. Thank you for inviting me.
Welcome, Mr. Bhattacharjee. Welcome.
Thank you.
We are entering into the next session. It's not working.
Working. Please carry on.
Okay. Professor Paul, are you in the line? Professor Paul?
Yes, I'm online.
Am I audible? Okay.
Yeah.
Are you am I audible to you?
Yes, you are able to. You're audible to me.
Okay. Now we are entering into the last session. It's our great that we have Professor Soumen Pal, Professor of Reproductive Medicine from Kansas Medical Center, with this webinar. In this webinar, just a minute. It's our pleasure have welcome. Please be with us. Just a minute. Please be patient. I have lost the page where the introduction has been written by me about Professor Pal. Yeah.
Don't worry about it. I can introduce myself. Don't worry. Okay.
Okay. I'm just giving a short introduction of Professor Pal. He's a professor and senior, and he did his PhD from Biophysics Molecular Biology of Calcutta University, and then he joined for a short time in as a assistant professor in biochemistry department of Pulmonary University, and after he joined Kansas Medical Center for his postdoctoral study, and then he joined as a faculty member of in Kansas Medical Center as a professor in the am I not wrong? Am I in not? It is in your department. The name of the department, Professor Pal, is it reproductive medicine and pathology? Pathology and reproductive medicine, right? Am I right? Reproductive medicine and pathology.
It's okay. Pathology is my department, and I'm also associated with another institute. So don't worry about it, Sumishta. I'll take care of it.
Please give your introduction, Soumendra. Please give your introduction. We are all keenly waiting for your introduction. Here is the platform is huge, fully covered with participants. So they are waiting for your introduction. So please give your short introduction.
So what I'm going to say here, I'm very thankful to the organizers for giving me this opportunity to talk about several aspects of the COVID-19. I am right now a professor at the University of Kansas Medical Center in the Department of Pathology and Laboratory Medicine. I also belong to an institute called Institute for Reproduction and Perinatal Research, where we study different aspects of reproductive biology, including placentation, and that's my area of research. I joined Kansas City University of Kansas Medical Center in 2007, and then I'm here since last 13.5 years now. So I think enough of this presentation and the introduction. Let's go to science. And I would switch to my talk, and somebody needs to confirm me that whether you can see my presentation or not. And I also request everyone to mute your microphone because otherwise there will be a disturbance during the talk. Okay, thank you. So I'm shifting to my presentation now. So I hope that you are being able to see the presentation right now. Can someone confirm me that one? Hello?
No, it's not showing right now. It's not showing.
It's not showing yet?
Dr. Paul, it's not showing.
Okay, hold on for a second. Let me share. So now I can see it. Am I right?
No.
Yes, it will come up. Give me a second.
Yes, now it is. Now it is visible.
So, yeah. Okay.
Yes. Now it is visible. Okay.
Thank you. So, I have made the title of my talk a very simple one, which is the known and unknown aspects of COVID-19. Before doing that, I would start my talk with a quote from Joshua Lederberg, who won Nobel Prize when he was only 3 years old. And he made this comment: the single biggest threat to man's continued dominance on the planet is the virus. There is a reason behind that, because we are loaded with virus. Our human body contains 380 trillion viruses. On the other hand, our own cells are about 37.2 trillions. So at a cellular level or at an organismic level, we are 10% human and 90% virus. So this is the concept of the virome, am I right? The human body contains different kinds of viruses, but not all of them are infectious. But those viruses which are infectious, they can do real harm. Here is a table here which shows what are the different pandemics and epidemics which humankind encountered from different viruses. We heard from the earlier talk that COVID-19 is unprecedented, but it's not true, because if you see the smallpox from 1880 to 1980, it has killed about 500 million people throughout the world. The Spanish flu in 1918 it killed almost 100 million people, whereas COVID-19 didn't reach to 1 million yet. On the other hand, the biggest war in humankind is World War II. At that time, 85 million people died, and most of them died from the microorganism-related diseases, not by the war itself. So it shows, virus, how dangerous it could be. Am I right? So when you're talking about viruses, we need to know what are the different kind of viruses. So David Baltimore, another Nobel laureate, he classified viruses into 7 different groups based on their genetic materials. If a virus contains double-stranded DNA and it is replicated, it's type 1. If it is a single-stranded DNA virus, it's a type 2 virus. Double-stranded RNA virus means type 3. Similarly, if it's a single-stranded RNA virus, it's called the type 4 RNA virus. And this RNA viruses, what they do, Dr. Sanjit, they also talked about it. They have an enzyme called RNA-dependent RNA polymerase. I'll go to next slide. This RNA-dependent RNA polymerase is a unique enzyme. What it does, it can recognize an RNA as a template and synthesize another RNA from it. So this particular enzyme is only present in viruses, not in any other microorganisms. So that's why the central dogma of life is DNA to RNA to protein. It's very different in viruses because they can also develop or replicate an RNA using this RNA-dependent RNA polymerase. So that's the uniqueness of a virus. And that gave them a more versatility to stay in this environment in the world to survive. So as I talked about, the RNA viruses are classified as type 4 viruses, and SARS-CoV-2 or any other SARS, those are class 4 adenovirus, which has a positive strand. Positive strand means sense strand. That's the genetic material is the strand, like the virus contains the genetic material. And then it generates another negative strand and then replicates its own DNA or RNA by using that negative strand RNA as the template and using this RNA-dependent RNA polymerase. So this is the genetic material, the structure of the SARS-CoV-2. It has ORF1, ORF1b, and these are non-structural proteins. So those are essential proteins required for the replication of the virus, including this RNA-dependent RNA polymerase, but those are not structural proteins. That does not give the virus its structure. On the other hand, structural proteins are this S, E, M, and N. This is the spike proteins, and these are the proteins which gives the structure. Right? This is the what is that called? Spike proteins. This is the nucleocapsid proteins, which gives the genetic material its own structure. I'll talk about another non-structural open reading frame or ORF. It's called the ORF3 and 3B. I'll talk it a little bit later because this is a very important ORF. I know people have found out recently. So there are different types of coronaviruses. Coronaviruses are not new to us. We have been the humankind has been infected with different kind of alpha and beta coronaviruses, which is especially the HKU1, which is very prevalent. We get common cold type of symptoms when this HKU1 infects us. On the other hand, these beta coronaviruses, these SARS-CoV, these are very different. These are coronaviruses, but they generate a much more severe symptoms when they infect a human being. There are coronaviruses for dog also, and and even the other I think especially for dogs, and they have already generated antibody or vaccines for those coronaviruses against dog. But we are still in search of the vaccine for the coronaviruses which are infecting the human being. I'll come to this subject in elaborate way later in my talk. So what I'm going to cover in my talk are the life cycle of coronaviruses and mode of infection. I'll briefly touch it. Then I'll talk about why this coronavirus is so infectious. And then I'll talk about a few other points as we go on. So, as Dr. Day indicated that, infection of coronaviruses is dependent on this SCU2 receptor, angiotensin convertase enzyme 2 receptor. but it also dependent on this protease, serine protease called TMPRSS2, transmembrane serine protease 2. So SARS-CoV-2 spike protein binds to SG2, and then through endocytosis, it's engulfed. Endocytosis means a process where the cellular membrane encapsulates the virus particle, and then it brings it within the cell. Then another round of membrane fusion takes place when these endocytic vesicles open up, and the virus gets into this cytoplasm, and then it enters into the system, where the cellular machinery is utilized to generate the viral particle along with the viral genome. So as Dr. There or my senior Sanjit, he talked about, this SCU2 receptor is very important, and it can be expressed in different organs. Am I right? But what it is also important, along with this SCU2, there are different proteases in the cell which are absolutely important. For example, this trypsin, this TMPRSS2, and another enzyme called furin, cathepsin, these are all proteases which are extremely important for this life cycle of this SARS-CoV-2. So, again, I'll briefly touch on this. So this is an SCU2 expression pattern. It shows the small intestine is most abundantly, this particular receptor is most abundantly expressed in the small intestine. But it is also known that the airway goblet cells, they also express not only the SCU2 but this TMPRSS2. So that's why this nasal epithelial cells, or upper airway, is very risky for this SARS-CoV-2 infection. So the question is, why bat? Why the birds? They are the reservoir of these viruses, am I right? So it turned out that the bat, the bird, the snake, they also have SCU2 receptors. They are not exactly similar with human SCU2 receptors, but they have very similar amino acid sequences. So, for example, the bat has 81% similarity, as the bird has 83% similarity of their SCU2 receptor with the human SCU2 receptor. So that means the SARS-CoV-2 can interact with this SCU2 receptor in those species, and they can get into the cells, but they don't induce any replication cycle or any immune reaction or any adverse effects. So that's why those species, those birds and bats, can act as a reservoir for this SARS-CoV-2 because they have these SCU2 receptors. So, I briefly talked about the life cycle, talked about different proteases. Now, I think the most important question is why it is so infectious. Why it is more infectious than SARS-CoV-1 or MERS-CoV? Probably many of you know that infectious virus, the parameter which is used to measure its infectious ability is called the R0 value, or the value which indicates from one single person how many other people will be infected. And it turned out that the median R0 value for SARS-CoV-2 is about 5.7. So what does that mean? It means it's a highly infectious viral particle. For example, hepatitis C, Ebola, or even HIV are less infectious than this SARS-CoV-2. There are more infectious viruses like mumps and measles, but 5.7 R0 value is huge. What does that mean? You can see here. So if R0 value is 1, from day 0 to day 60, the number of, 1 to 1.1 difference can change about 15,000 or increase 15,000 more infections in 60 days. Just 0.1 change in R0 value. So now you can think the R0 value of 5.7 of what it could be. Am I right? So how we are not getting this much infection? Because we are taking protections, we are locking down, we are getting masks on, we are taking protection. So that's why we are not seeing this huge infection rate yet. But this virus is highly infectious. So please note that in your mind. So before talking about why it is so infectious, I should introduce you with the immune system briefly. we in our body, we have basically two different kinds of immune response. One is called innate immunity. So that immunity is, we all are born with that immunity. It's non-specific. It provides the general defense mechanism. And this adaptive immunity, where with the immune system learn about a specific infection and generates a defense mechanism against that one. So this innate immunity is mediated by cells like macrophage, natural killer cell, eosinophils, basophils, all are blood cells. On the other hand, this adaptive immunity is mediated by the B cells and the T cells. So the B cells generate the antibody, which is the humoral immunity, and that means it is in our blood flow, in the plasma, and it can bind with an antigen and take it away. On the other hand, there are the cell-mediated or T-cell-mediated immunity, where it kills the cell which are infected. So there is a difference in timing, right? The innate immunity can be active within hours. On the other hand, this adaptive immunity takes a long time. And there is a passive immunity which is induced by vaccination. So our body does not know it, but we inject a particular antigen to teach our body how to generate immunity against a virus or a bacteria. So now you have learned about this innate and adaptive immunity very briefly. I'll touch more into this innate immunity. So, how our system know that there is a virus and a bacteria, okay? They recognize some molecules which are called the pathogen-associated molecular patterns, so like lipopolysaccharide, endotoxin. So virus and bacteria, they generate those kind of molecules. On the other hand, human body does not generate those molecules. So our system, we remember we came through evolution, billions of years of evolution, am I right? So we are selected for the best defense mechanism. So what happened, like our body, they have receptors which can recognize these pathogen-associated molecules. These are called pattern recognition receptors. And these receptors are divided into another subcategories like toll-like receptor, nod-like receptor. So what they do when a bacteria and virus, they infect a human body, these receptors can recognize those molecules which are secreted from bacteria or virus or within the cell. And then what they do, within minutes, these receptors then generate a signal transduction mechanism in the cell, and the immediate molecule which are generated is interferon molecules. It's kind of cytokine, and these interferons then activate the macrophages and make it a phagocytic cell. So the cells which are infected, this phagocytosis procedure that kill those cells. But if that mechanism does not work, then it generates an inflammation reaction. So, and that is the acute phase innate immune response. So, and that response involves the neutrophil as well as other pro-inflammatory cells, the innate immune response cells, and then we get fever, we get all this inflammation reaction. And the question of cytokine storm, which Dr. Day talked about, that is the response from the acute inflammation. So now, so if I summarize these two aspects, then we can talk about two different arms of the immune response. One is the immediate interferon response, where the interferon alpha and interferon beta are generated, and it generates a mechanism where a phagocytic cells kills the cell which is infected with a virus without generating a huge inflammatory response. On the other hand, it can activate a chemokine or cytokine response which generates the inflammation. So now what happens, like for SARS-CoV-1 or other type of response is sufficient to take it away. There will be mild fever, mild, mild inflammation, but the main mechanism will be interferon response. But, so when people realize that SARS-CoV-2 is really infectious, they found out what is going on. So there's a paper came out in Cell in March, and they showed that, the SARS-CoV-2, it actually changes the pattern of interferon response. What happens for normal common cold or other type of infection, we see that the high level of interferon alpha and beta and gamma, they are elevated. On the other hand, the chemokines, interleukin 6, CXCS, or they are down-regulated. They are not produced in that much amount. On the other hand, for the COVID-19, what happens, these interferons are not produced that much, so they can evade this system, this interferon surveillance system. Rather, what they do, they induce the other pathway, the interleukin 6, interleukin 1, and chemokines. So that means they are evading the initial defense mechanism, rather they are promoting this acute phase inflammation, which leads to this lung injury, what Dr. Dept talked about, this acute respiratory distress syndrome. So then question comes, why and what is the mechanism behind this evading aspect of SARS-CoV-2, where they can evade this interferon system? It turned out, and I mentioned about this open dating frame 3A, 3B, am I right? So it turned out that this is the culprit. It was found out that this ORF3A can have a truncated version called ORF3B. This paper is just coming out. It's not published yet. It's a preprint form. So this ORF3B it can be only 22 amino acid long peptide fragment. So the paper, it showed that this ORF3B can have multiple mutations. This asterisk shows different mutations of the ORF3B, and which generates truncated proteins. Truncated proteins means they could be 22 amino acid long, 56 amino acid long, 78 amino acid long, or 118 amino acid long. So this truncated ORF3B, which is a non-structural protein, what is its role? Its role is to downregulate the interferon response in the cell. So this is the plot here, and you can see that this truncated ORF3B can reduce the interferon response. It actually affects the transcriptional mechanism, where this interferon beta, alpha, they cannot be synthesized, and that's why this immune response, the initial defense mechanism, cannot work. So this is one of the mechanisms. That's how the SARS-CoV-2 is infecting the cells. Now, the other mechanism is structure. So it was found out that this SARS-CoV-2, the spike protein, they can be in two different conformations. So that means, it has the receptor binding domain, or is the SCE2 receptor binding domain, and this domain can be, in a lying stage or standing up stage. So receptor binding domain is in standing up state. It can be recognized by our antibody system, our adaptive immune system. But when it is in a different conformation, in lying stage, it cannot be recognized by our immune system. Happens, and this is not true for this SARS-CoV-1, like the initial SARS-CoV. Their conformation is not like that. They don't have this lying stage. So what happens? When this receptor binding domain is not in a standing state, or the SCE2 receptor cannot bind, but it is also not recognized by our immune system. But this virus, when it is very close proximity to this SCE2 receptor, then it changes its conformation, and then it can readily bind to this receptor. So it's a very clever mechanism, while it is evading the immune system, but it is only active when it's in presence of the SCE2 receptor. And that's how this paper came out in PNAS and also in 2020. And it shows that it can evade the adaptive immune response by just changing its conformation of the spike protein. So it can evade the innate mechanism, the interferon response. It can evade the adaptive immune response, and not only that, it occurs a mutation in the region where there will be a protease-mediated degradation. So when after endocytosis, when the virus is getting into within the cell, the endocytic vesicles needs to be fused with the viral membrane, so that the viral DNA can get out of the endocytic vesicle, and it can be replicated. So if that membrane fusion is not efficient enough, then viral DNA or viral RNA cannot be into the cytoplasm. Am I right? So it turned out that SARS-CoV-2, it has a mutation which is now recognized that due to that mutation, this S2 proteins is now recognized by the furin. It's another protease in the cell. This furin is also recognized by the HIV virus, and that's how the HIV is so infectious. So due to this furin-mediated protease cleavage, the viral membrane protein can fuse with the endocytic membrane, and that's why the DNA, the RNA can come out. And this process makes the RNA release more efficient and makes it really, really infectious. It has been also proposed that there could be other receptors for this SARS-CoV-2, and that's why it is more infectious than SARS-CoV-1. So there are four mechanisms. First, it can evade the interferon response. It can evade the adaptive immune response. It can recognize by furin so that the RNA release is more efficient. And also it might have other receptors beyond ACE2 that can facilitate its infection into the cell. So, how we can prevent this infection? There are two different ways. Right? We can prevent an infection, or we can treat an infection after the infection has commenced. So, as Dr. Day talked about and other people talked about, the best mode of prevention is generation of a vaccine. And this table shows the different ways people try to generate this vaccine. Like first of all, the virus mode, where the whole virus, inactivated or weakened virus, was used to generate the vaccine. The viral vector have been used to generate a vaccine. The nucleic acid, the plus strand mRNA, the part of the mRNA has been used, and also the protein-based method. And I'll briefly touch what does that mean. So weakened virus can be injected into the cell, and then antigen-presenting cells can recognize the spike proteins or other part of the virus, and it can elicit an immune response. On the other hand, the viral vector vaccine, which is the Oxford vaccines, the Oxford University vaccine, they are using this particular method. So what they are doing, they are using a double-stranded DNA virus like adenovirus, which was isolated from chimpanzee, a primate, so that primates are very close to human. So those viruses can replicate within the human because of this, the similar nature of the primate and human beings. So then they clone a part of that spike gene into that adenovirus, and then they transfer it into the cells, and the antigen presenting cell will be then recognizing that virus, that part spike gene, and will generate the immune response. What a new mechanism is, rather than using the protein as a target, they are using the genetic material as a target. So, for example, this RNA can be utilized, to deliver into the cell, and that RNA will generate the viral protein, and that viral protein will be recognized by the immune system to generate antibody. So this is one of the delivery mechanisms. Among the 26 candidate vaccines which are now in clinical evaluation, I'm going to talk about 2 or 3 vaccines. This is the AstraZeneca, our Oxford vaccines, which is known as CHAdOX1S, like chimpanzee adenovirus OX1S. This virus is now in phase 3 clinical trial, and we all know that the Moderna, which is using the spike protein mRNA as the source for the antigen, is also in phase 3 clinical trial. These are the leading 2 candidates right now, for the generation of viruses, in my opinion. So, we have to be realistic here. It takes a lot of time to develop a vaccine, and this is just some numbers. The vaccine against typhoid took 105 years to develop. The lowest number here, you can see the measles virus, which took 10 years. Our own vaccine against the rotavirus is developed by Dr. M.K. Van, who just passed away probably a month ago. He discovered that mechanism in 1985 and he got approval in 2014. So this is normally the general timeline, because this is the guideline where the phase 1, phase 2A, phase 3, then licensing. This procedure takes a lot of time. But in this unprecedented situation, every rule has been bent, and now this phase 1, phase 2, phase 3 clinical, especially the phase 1 and phase 2 clinical trial, they are merged together, and phase 3 has been accelerated so that the vaccine can come as soon as possible. So I talked about two different vaccines: the Moderna mRNA 1273 vaccine and the chimpanzee adenovirus vaccine developed by the Oxford group. Why these two vaccines are more important? So these are some clinical data. I just want to point out here, when the vaccine is not added, this shows the antibody titer, this shows the receptor binding domain mediated immune response. And the most important aspect is this one, where they use the normal SARS-CoV-2 to do a plaque formation assay, and they use this vaccine to find out how much it can, this is the PRN80, so 80% diminution or inhibition of that plaque formation assay. So you can see that this Moderna virus is extremely active against this SARS-CoV. The Moderna vaccine is extremely active against this SARS-CoV-2 virus, the whole SARS-CoV-2. This is an artificial SARS-CoV-2 data. Here is the this New England Journal of Medicine reference. If you're interested, you can look at it. But this is extremely positive news. Am I right? But this data were done in vitro. Basically, the viruses are generated in a cell line. It has not been tested. The efficacy has not been tested in vivo, really, except the antibody binding. So what they did in a very recent paper, they actually injected some primates, some monkeys, with this virus, and they used this vaccine. And they showed that this vaccine can generate an antibody response in a living monkey, a living primate. So that is a tremendously helpful data. So not only they have generated in a cell culture model this data, they also have generated this model in a living monkey, showing that this virus can be really active. And that's why now they got into phase 3 clinical trial. This Oxford virus, this chimpanzee adenovirus vaccine, this is also showing an extremely positive responses. You can see that when there is like a negative control versus this positive control, it shows that after vaccination, the amount of like an antibody which is produced, they measured it by ELISA, it's really high, and it is even higher when they have used a booster dose, So at least two of the vaccines in their first clinical phase 1 and 2 stage showed really positive responses. However, we need to be extremely cautious. So cautious means, although it showed responses in primates or monkeys are not human. And what happens if there is not, the antibody is not perfect enough, it can generate antibody dependent enhancement. So rather than inhibiting the viral infection, it can promote the viral infection. It's like a friend can be the biggest foe. It's like that situation. So what happens if the antibody is not strong enough, then it will bind to the virus, and then it will also bind to the cell, which can generate this response, but it will not generate the response we want. Rather, it will induce these pro-inflammatory cytokines through these toll-like receptors, which I talked about earlier. And this antibody-dependent enhancement is not unprecedented. In 1966, the respiratory syncytial virus vaccine, we didn't able to generate that vaccine because it actually generated an antibody-dependent enhancement in phase 3 clinical trial. That also, this particular event also been noticed for dengue virus, and we have not generated any vaccine against that. And Ebola virus, we got a vaccine, but we had encountered the DD earlier. So we have to be extremely cautious. There is no way we can generate an antibody in 1 month or 2 months notice. It needs double-blind placebo control for that kind of analysis. So I talked about vaccine. Now I'll talk about why some people are more susceptible. Why only 5%, 10% people are really, generating this ART syndrome, and why not? We talked about this cytokine storm, this ART syndrome. So it turned out that the culprit is single nucleotide polymorphism. So what is single nucleotide polymorphism? We have our genes, but we are not similar. We all have different faces. We are all human, but we are not similar to each other because we harbor different kind of mutations in our genome or genetic material. For example, there is a gene called OCA2. A single nucleotide polymorphism can generate a brown, and that gene can generate a brown eye versus a blue eye. So a blue-eyed, beautiful person is nothing but a mutated version of you. Okay, so how people do that kind of analysis is called genome-wide association study. One of the most successful GWAS study was done with malaria. Till date, in Africa, malaria kills about 1 million people, or 500,000 to 1 million people each year in Africa. And it turned out that the African population, they have a single nucleotide polymorphism in one of the toll-like receptor 2. This particular single nucleotide polymorphism make African population most vulnerable to malaria, because it cannot elicit the toll-like receptor mediated response properly. So such a genome-wide association study was done recently with population in Spain and Italy, because Spain and Italy was really, really affected. And they found that what they did, they took the genome of the people who are really affected and the genome of the people who are not affected. And that paper published in New England Journal of Medicine. And I'm sorry, somebody is actually turned on the microphone, please. I'll appreciate if you turn off the microphone, please. So that GWAS assay identified 2 different regions of the genome which are the culprit, that single nucleotide polymorphism. One is this region, which harbor this particular genes it's in the chromosome 3. And these are the genes CXCR6, which chemokine receptor 6, chemokine receptor 9. I talked about chemokine-mediated inflammation response earlier. So it showed that this chemokine receptor regions, this region, the single nucleotide polymorphism in this region, can really induce the inflammation response and create this ART syndrome. And somebody asked a question, the relationship with the blood group. The other genetic locus which was turned out to be important is the ABO blood group region. It turned out that people with O blood group will have less severe SARS-CoV-2 mediated response than people with A blood group. So people with A blood group are more vulnerable for the SARS-CoV-2 infection than the people of O blood group. So these are the 2 locuses which have been identified as the most important region for this SARS-CoV-2 infection. Another recent study which just came out also indicated that African American population, some race may have the single nucleotide polymorphism in the ACE2 and the TMPRSS2. Especially the African American population, they have this mutation which can generate an arginine to glycine mutation. And probably this mutation is not present in people in Vietnam or Mongoloid group. That's why they are not that sensitive to this infection. And the last one is why Indian population and the Eastern population are not sensitive, because there's a paper came out in PNAS. This also showed that BCG vaccination is really important. When there is BCG vaccination, those countries which are following the BCG vaccination pattern, the death rate is much less compared to those countries which do not adopt the BCG vaccination policy. And United States is one of those countries which does not have a BCG vaccination policy. You can see how East versus West, right? It shows that how mortality rate in West is higher than East because the vaccination started much early in East, like the countries like India. So these are the causes, am I right? So the single nucleotide polymorphism in this chromosome 3 and ABO blood group, the changes in mutation in the ACE2 receptor and TMPRSs, and the BCG vaccination, these things actually changing the pattern that which person will be more infected or more show more severe immune reaction upon SARS-CoV-2 infection, and who will not generate that inflammation reaction. We also know that old people are more susceptible. Again, the immune mechanism is involved. I will use two different terminology. One is called inflammaging, that is aging-related inflammation, and immunosenescence. So the senescent stage of the immune mechanism. So the regeneration power of the body, it dies, it slows down with age. So what happens, our body, it generates more dead cells, when we are aging. And that dead cells have different lots of DNA, right? We have DNA, it's double-stranded DNA. We have mitochondrial DNA. And those material, our body does not know whether those are viruses or my own DNA. Truncated DNA, they consider it as a virus, double-stranded DNA virus. Mitochondrial DNA, they consider it as a double-stranded virus. So what they do, our body, when the more and more cells are dying with age, they induce the pro-inflammatory signal, and they reduce the anti-inflammatory signal like IL-1, beta, IL-18. These are anti-inflammatory signal. So age reduces the regeneration power. More and more cells are dying, generating their, the molecules which can be, induce an artificial viral or bacterial infection pattern. And that's why with age, we get more inflammation. So we get pains in our body. Older people, they complain, we are getting a lot of pain here and there. So this is, the cause is inflammaging and immunosenescence. Our immune system is most active, the adaptive immune response. So the inflammaging relates to the innate immune response, and immunosenescence relates to the adaptive immune response, especially B lymphocyte, T lymphocyte. We have most number of lymphocytes when we are younger. A child has the highest number of this B lymphocyte and T lymphocyte because they need to learn more. With age, we have reduced number of lymphocytes, and with time, these cells also acquire mutation and they undergo aging process. And they become old. The immune cells also become old. That's why this immunosenescence comes up. So older people, they have this inflammation due to the inflammaging, and their adaptive immune response is weaker. So together, they generate a scenario when SARS-CoV-2 will be infecting them. They will be much more vulnerable against that infection. So what are the possible drugs for this SARS-CoV-2 treatment? There are, we talked about prevention, now we are talking about treatment. So, somebody talked about, can we inhibit ACE2 receptor? Yes, people are using chloroquine. Chloroquine, what it does, ACE2 receptor needs a glycosylation step. Once the protein is generated, it needs to be modified with a sugar molecule. And that glycosylation step can be inhibited by chloroquine. And people are thinking that, it can be used as a prevention. But the chloroquine is a non-specific glycosylation inhibitor. So it can inhibit glycosylation of other proteins also. So that's why, it can have non-specific effect. This remdesivir, which is inhibiting the RNA-dependent RNA polymerase, what it does, remdesivir becomes, after metabolism, it becomes a ribonucleoside. So it gets integrated into the viral DNA molecule. But the same remdesivir will be integrated into our own RNA. and our cellular system will not be working properly if we are having a prolonged treatment. So these are drugs which are only given when there is a severe infection, when there is a life-threatening cause, when the survival of the patient is more important than their long-term benefit. So these drugs are good, but they are not for everybody. These are for only very acute case scenario. Then you can add those to save those lives. The same thing is true for dexamethasone, which inhibits the immune system. It is a glucocorticoid, and glucocorticoid is a steroid receptor. It can go to the DNA and can inhibit the synthesis. I talked about toll-like receptor. This toll-like receptor signaling can generate pro-inflammatory signals. On the other hand, the glucocorticoid, it can bind to the DNA and then prevent this transcription of those pro-inflammatory signals. And that's how dexamethasone, this steroid, can work. But this can make you vulnerable to other infections, right? Because you don't have the defense mechanism there. So that's why the HIV patients, they mostly die from pneumonia. So if you use dexamethasone, you will have a chance to have secondary infection. So these are for life-threatening treatment. I'll skip this slide, but I would like to talk about this molecule RFL 100. Just the day before yesterday, it turned out that this is right now the most potent drug to save people who are going to ventilator. So these are these are vasoactive intestinal polypeptides. This RFL 100. And these polypeptides are known to be anti-inflammatory for a long period of time, because, especially for lung, because 70% of these vasoactive intestinal polypeptides, which is one of them is RLF 100, they go to lung and they bind to lung alveoli cell because their receptors are there. And once they are there, what they do, they inhibit the inflammatory reaction. So that's why this RLF 100, which is already got the FDA fast track approval and approval for treating patients, it is turned out to be the most potent drug right now to treat the SARS-CoV-2 infection. I'll briefly touch that, but there are other ways where bioinformatics, artificial intelligence can help our drug development. So, for example, human body has 30,000 known proteins, and they all interact with each other. It's called human interactome. So what this artificial intelligence is doing, they're finding out how SARS-CoV-2 proteins have their own interactome, how they are hijacking human protein and then generating their own interactome. And then what are they doing, the artificial intelligence also finding out how different drugs can block that interactome. And that's how they are coming out with specific drugs for SARS-CoV-2, MERS-CoV, through this drug repurposing mechanism via the interactome, protein-protein interaction, pathway, and using the artificial intelligence. And that has identified a few of those drug candidates which are already being used, FDA approved, and and that's why, and people know that they might not have huge side effect. And these drugs are also in trial right now. People are using these drugs in different aspects. And I hope in a few months, probably some of those reports will show up. I'll briefly touch about herd immunity. It's nothing. Herd immunity means you generate immunity in among as many as people possible, so that virus cannot infect or propagate. So R0 value becomes, the R0 value becomes less. It turned out that for SARS-CoV-2, to get that herd immunity, we need to have antibody raised among 55% to 82% population. But it turned out it's not easy because there is a serological test. So serological test means when there is a viral infection, that our body generates antibody if we are generating immunity. So after 2-3 months, you can test for that antibody in our body. So that's called the serotest or serological test. And so what happened, the same a study published in Lancet, they used about 7,000 patients. Sorry, not 7,000, 51,000 patients for their serological test. Their goal is to find out how many of those patients who are infected with COVID-19 have measurable antibody after 2-3 months of infection. Unfortunately, it turned out only 4.6 to 5.7% people among those 51,000 infected patients have antibody. So that means via infection, it might not be possible to have herd immunity. To generate that herd immunity, we need to get the antibody response via vaccination, because then this defense, this avoiding mechanisms which I talked earlier, like the blocking of interferon response, evading the adaptive immune response by the normal native virus, that cannot happen for a vaccine which is generated a partially truncated proteins and teaching our immune system to know about that particular factor. And it turned out, it is possible. A paper came out in Cell. It shows that, now, although after 2-3 months the viral titer is less, but after infection we can have both helper T cells, which generates the antibody response or humoral immunity, as well as the CD8 T cells, the cytotoxic T cells. They are much higher compared to unexposed people. So this gave us a real hope, am I right? Because there is an immediate response. And that hope was increased by another study in Nature Medicine. They showed that, not only the CD4, CD8 cells, but this immunoglobulin M and IgA levels are also up, when people are infected with COVID-19. So, this is the data from that paper. Actually, I missed it. This shows that these are the IgM, IgA. This is the T helper cell response and the cytotoxic T cell response. So these are classic parameters of adaptive immunity. So although the study from Spain showed that only 5% people have serum positivity after 2-3 months, this study shows that the actual immune response are being generated. It might not be long running with the native viruses, but with a vaccine, it is possible to get that. So one of the other aspect is memory cells. So when an infection, our immune system knows about an infection, after that infection is eradicated, we keep some cells called memory cells. So they are in a dormant stage. But when the secondary infection comes in, when we get encountered with the infection one more time, then those memory B cells, memory T cells, they work. So this study in Nature Medicine, they showed that this against SARS-CoV-2, we have these memory B cells, both in dormant stage, which is CD21+, CD27+. These are the markers for those dormant B cells, as well as they can find out the active B cells, which is like a memory B cells, CD21+, CD27+. So that means not only we are generating antibody, we are not generating the CD4 activated CD4 cells, CD8 cells. We are also being able to maintain some portion of memory B cells or memory T cells. And that shows that an antibody response, a vaccination is possible. It's not impossible for against SARS-CoV-2. So a few aspects people always ask, in which surface the SARS-CoV-2 lasts longer. Should I touch a metal? Should I touch a plastic? Or if I get a letter, after how many days I should touch that? And so this is a study published in New England Journal of Medicine, and it showed that the surface which is most dangerous is plastic. You can have the SARS-CoV-2 until 72 hours, a live SARS-CoV-2 on plastic. On the other hand, on steel, it will be surviving for 24 hours. On cardboard, around 20 hours. On copper, it's only 8 hours. Okay, so and on aerosol, it's only 3 hours. So this is a study which shows that the plastic, if don't touch plastic for 2-3 days, if you think that that might be infected, you can touch steel after 2 days, but not plastic. So another aspect is whether asymptomatic patients, they infect other patients. It's true. And it's true means this study showed that, it's a study in Nature Medicine, again, published in Nature Medicine. It showed that the asymptomatic patients, they shed viruses longer than the symptomatic patients. Here you can see that a symptomatic patient can shed a virus until 25 days. On the other hand, an asymptomatic patient can shed the virus until 35 days. So, so it is true that asymptomatic patients, they infect other people. So the request is the younger people who does not have inflammation or the immunosenescence, they might be asymptomatic, but they can be infecting other people. And so they need to be really, really responsible. These are actually scientific data. We also now know that the airborne transmission happens, and with these two studies, which the World Health Organization, they have admitted that airborne transmission is possible. So why mask is important? You can see this plot here. This is the plot in Italy, and this is the plot in United States. It shows that these circles shows the point when mask use was made mandatory. But even after lockdown, the SARS-CoV-2 infection was going exponentially, and it only started to flatten when people started using mask. So airborne transmission and mask use is the way to prevent, if not the social distancing alone, not the lockdown alone. So young people need to be responsible, because even though asymptomatic, they'll infect other people. And mask use is absolutely important, because scientific data shows only use of mask flatten those curves in those countries. I'll lastly touch a few unknown aspects. My subject is pregnancy. Still, we don't know whether SARS-CoV will affect pregnant women and how it will affect the baby which will be born. It turned out that placenta, which the barrier between the mom and the fetus, does not have much SU2 receptor, but the mom side, the vasculature, the blood vessels, which transports nutrient to the placenta, it turned out they might be affected by the SARS-CoV-2. So we need to have more time to study how that affects a baby's development. We didn't have enough time for that. We also don't know whether there are single nucleotide polymorphism which are beneficial. So there are asymptomatic patients which, it could be that they have single nucleotide polymorphism which is beneficial. So we really need to know about that. Or it is possible that in those patients, the proteases are defective. So that's why all the infection is taking place, the genetic material is not being released there, or inefficient assembly. So more researches are needed to understand why asymptomatic patients are asymptomatic. There is still no definitive answer. We know that SNPs induce more immune reaction, but we don't know about the beneficial SNPs. So lastly, what we should do, as I talked about, take precaution, use mask, because scientific data shows that mask is the most important preventive mechanism for preventing this SARS-CoV-2, and also be respectful to each other. Especially the younger generation, don't infect older people. Lastly, I would like to say this word. This is the highest possible level effort which mankind is doing to prevent a viral infection, and our history shows that we always win against viruses or microbes. Those are intelligent, but we are more intelligent. And so we will survive. With that, I like to thank Sharmishta and other organizers, because of you, I could talk about this. And these are my lab members. I am very proud of them. They helped me, to learn about these subjects, and they always motivate me. So with that, I'll be happy to answer questions. Thank you. Hello? Sharmishta? Oh, hi, Sanjit, how are you? I should have been I should say that I am so happy to see it after so many times, so many years.
Excellent.
So the question has been put from chat box.
I am trying to figure out how to go to chat box. Okay, I can see that now. Sharmishta, will you help me to frame those questions?
Achha, let me see whether I find going to the chat box. Okay, but unfortunately, I could not also find most of the questions. Bithin Kumar Maji, I can say, Diptendu. Let me quickly go through that. So everybody can listen to me?
Yes, sir.
Yes.
Okay, so can I read out the questions, organizers? Or
yes, you can.
Sure, please go ahead, Sanjit.
Okay. Oyantika Sarkar, can we decrease the spread by lowering the R0 value?
The R0 value, it's a measure of infection. So it's not something, a parameter which you can change. Obviously, our goal is to reduce the R0 value. It is called RE value, our effective value, via this social distancing and by putting on mask and washing our hands. So R0 value is a measure, it's a scientific parameter when infections are going on. It's not a biological parameter or biological gene you can reduce it. We have to reduce it through this mechanism or by vaccination and other things. Did it answer that question?
Okay. Yeah, I hope that she is satisfied with your answer. But if she has more questions, she can go ahead with that. And also Aditya Nath, that is why COVID-19 is a zoonotic disease. I think it is a statement.
Yeah, you're right.
Right. And Diptendu Sarkar, what is herd immunity? Is this useful to protect community against COVID-19 spreading?
Again, I said herd immunity is a terminology that means where most of the people in a population are all have the immune response against the virus. So the virus does not have a host or enough hosts where they can replicate and spread out. And I just showed the data that herd immunity by natural infection is very difficult to achieve, because then we have to get infection for 85% of people, and that means a lot. If India is 100, India have 100, crore people. So that means we have to infect 100 crore people to get herd immunity, and that is not a realistic value. So rather, what we should do, we should use the vaccination to generate that herd immunity. And it will not it will not end up killing 2 or 3 crore people.
Okay, Sharmishta. So would you take over the question?
Okay, yeah, I'm taking off the session.
Sure. And Bithin Kumar Maji, there is one question from Bithin.
There is one question from Bithin Kumar Maji. Soumen, here is one question. Bithin Kumar Maji is asking why the rate of mutation in SARS-CoV-2 is very high within a short lifespan. Why?
So, it's not any higher than any other RNA viruses. You need to understand that, because first of all, the rate of replication is small genetic material, and the viruses, what they do, they try to suppress our editing mechanism through which we make sure that mRNA sequence is proper mRNA sequence and there are replication editing mechanism. So what are these viruses genetic material? They have some proteins. They actually promote the viral replication as much as possible. Their whole goal is to generate more viral particles. So their fidelity is not perfect, and that's why they generate more mutations.
Okay. One more question from Anirban Sarkar. He is asking about, can you explain the role of N-acetylcysteine and glutathione used in many cases of COVID-19 treatment?
So N-acetylcysteine and glutathione,
Cysteine and glutathione.
They have the sulfur hydryl bond, SS bond, disulfide bond. I don't know whether they have any specific mechanism or not, but probably what they are doing, those things are affecting this, mitigating the secondary effect. So when a viral infection is taking place, one of the things that happen in the inflammation reaction, and inflammatory molecules, what they do, they generate the hydroxy radicals, oxidative radicals to kill cells. Am I right? So when you have glutathione or the sulfide molecules, they can scavenge those oxidative radicals, and that's how they can prevent the damage to their tissue.
So Arno Banerjee is asking about NSP1 protein ribosome binding. NSP1 protein, which is a ribosome binding protein, can it be? Is it possible to target it as a drug therapeutic against COVID-19?
If there is a specific drug which can bind specifically
NSP1.
to NSP1, it is possible. But that against that. At least I know that the artificial intelligence didn't come out with a drug against that one. So, but this is certainly possible.
Yeah.
I have one question.
Okay,
Soumen, I have one question, just one question.
Sure.
Is there any association study for interleukin receptor gene? Is there any association with COVID-19?
So, as I told you, the most elaborate GWAS study was done in Spain and Italy. That paper came out in New England Journal of Medicine, and they didn't come up with significant changes in those receptor locus. Rather, they found the significant changes in two regions, which have this chromosome 3 and chromosome 9. The chromosome 9 is associated with ABO blood group, and chromosome 3 is associated with CXCR9, CCR. I forgot those 6 molecules. And I can share, if anyone wants to know, I can share those publications with you.
Okay. We have more questions, but really it's a very enchanting session and really brainstorming for us. And it is also expected from you, Professor Pal, as you have received different international awards for your continuous research excellence. And we have know that, we all come to know that it's your continuous research excellence, due to your continuous research excellence, you have received continuous NIH grants, and you are the editorial board member of various scientific journal like Nature, Nature Genetics, Nature Medicine, PNS, Nature Communication, Scientific Reports, etc.
I need to rectify you. I'm not a part of the editorial board member, but I'm part of the peer review, peer reviewers. So I review papers.
Peer reviewer.
Yeah, but I'm not an editorial member. That would be immense. But can I say something, Shamishka?
Yeah, I think you would be. So she has made a future statement. So I think sooner or later we will find you.
Please proceed, Soumendra.
Thank you. So if anybody has any further question, feel free to email me. I'll try to answer them as I can. And happy to.
Professor Madhusudan Ghosh, he is asking about one question: how long the virus can active in liquid substances?
Liquid substance means it depends on what kind of liquid you have, because
what kind of liquid?
Because the virus is
watery or
if the viruses are in hydrophobic molecule, they should not last longer, because we know that 70% alcohol kills them within 30 seconds. Am I right? So because the viral protein is more hydrophilic, and that's why they survive. If you have a water molecule and a saline molecule, probably they will live longer. But if you have hydrophobic molecule, they will not live longer. That's why we use this hand sanitizer, which has those organic solvents.
Yeah, that's why the soap and all these things are there also, degrading to some extent. They are preventing.
No. Actually.
And how long the antibody titer exists?
Again, it varies from person to person. As you can see that the studies, several studies in Spain and Italy, they showed they are done after 2 months or 3 months of infection. Still 5% of the people, they have those antibodies in them. Again, it varies from person to person. How much immune response has been generated in one person, it is dependent on that aspect. But memory B cells or memory T cells, they can last much longer. They can last years. For example, for measles, we are vaccinated only once. So that's why we don't get measles anymore. On the other hand, for flu viruses, we need to get vaccination each year, because of that the memory cells does not last more than 6 to 8 months. So it depends on types of antibody type vaccination, and we still need to know those parameters. That's why this phase 3 clinical trial is going on.
Okay, thank you, Soumen. Please be with us, and now I am hand over the session to our
I think there is
coordinator.
one more question. If we are not getting late, I think another question from Bithin Maji. So, is single vaccine be effective against highly mutated different strains of SARS-CoV-2 for all over the world population? Was it answered?
No, but I can answer that one. Again, we don't know about that it will be mutated, but in general, the mutations in RNA viruses, they are generated against, they are prone to be activated in a way so that they can evade the interferon response. So for adaptive immunity, most of those mutations, they don't they are not that effective. I came to know about that because Dr. Anthony Fauci and Francis Collins, they are discussing about this aspect, and there is no scientific data yet, but they have a video while they are discussing about that, and they talked about it, that RNA viruses, when they are mutated for adaptive immune response, most of the mutations are still vulnerable.
Yeah, I think that's why it did not happen for the MERS or the SARS-CoV-1. I mean the earlier one. So it did not mutate, so rapidly. That's why it was contained in a very small span of time, and also in a larger, smaller community. That was another.
Obviously, they are mutated high, their rate of mutation is higher, but most of these mutations come on those genes like ORF3A, ORF2B. Those kind of genes are more prone to mutate.
And its gene is also very unique. So this is also only 30,000 nucleotide long, yet it expresses around 29-30 proteins. So that is also very unique for this RNA, this type RNA coronavirus.
Yes, I would ask you guys to watch that video where Dr. Fauci and Dr. Collins are discussing among themselves. Okay, so if I answered most of the questions, then I think, Mr. you can go ahead and finish this session. I will turn off my video then.
Okay, Soumen, stay with us.
Yes.
And now it is the session for vote of thanks. May I request Dr. Sarojendra Chakraborty to give the vote of thanks?
Okay.
May I request Dr. Sarojendra Chakraborty?
Okay, thank you so much, Mr. Hello, a very good evening to everybody, and my compliments to all the dignitaries, speakers, and participants. So ultimately, we have stepped into the last lap of our webinar, being aired under the title, The Emerging Pandemic Crisis, Physiological and Socio-environmental Imperatives. But the last lap is often the most difficult lap, whether in a long drawn race or in a bout of COVID attack, or pronouncing this vote of thanks in pandemic endgame. We are indeed proud to state that this is an international webinar being organized for the first time since the inception of our college in 2015. So today is a great day for us as we remain silent testimony to the golden moments. Truly, this will be a trailblazer for all the years to come. But everything has an end, so do this webinar also. The earlier 2 hours has remained very fascinating for us, especially when everything around is getting so disarrayed and disobeyed by the virulence of COVID-19. It was really a very good teaching learning session to the cusp of information and excellence. IQAC takes special pride to host this grand webinar in association with the Physiology Department of Sister Nivedita Government College, for which I must express my thanks and indebtedness to all the learned participants, our beloved students, research scholars, members of IQAC, teaching and non-teaching fraternity of my college and other institutions as well, scientists across the globe who have spared their valuable time to make this grand show a highly successful one. It is because of your wholehearted cooperation that this program has taken a true transoceanic dimension. Such a webinar was really the need of the hour, for which we offer our gratitude to our most reverend OIC Madam, Dr. Socio-environmental Bhattacharjee, for her well-consoled guidance right from concept to execution till today. It was a long-cherished dream to hold such webinars that leads us to fountains of deep learning, deep ecology, and eco-pedagogy. It is indeed my pleasure to thank Dr. Indrani Chakraborty, Head of Physiology Department and one of the conveners of this webinar, for her brilliance in conceptualizing the structure and framework. Her introductory speech has set the right tone and template for the grand events ahead. I must mention the superior efforts unfurled by Dr. Atanu Shah, the organizing secretary of this webinar and member of IQAC on one hand and faculty of physiology on the other. Never did I see him tired in extending his holistic help and support in all matters related to this webinar. I am privileged to thank our veteran Professor Sujoy Dasgupta of Physiology Department, who always remains at the helm of advices, steering us to the righteous path of success. All the panelists are doyens in their fields and deserve high applause. Their remarks were incisive, decisive, analytical, and well debated that enriched us in all possible ways. Dr. Sanjit Dey, Professor of Physiology, University of Calcutta, spoke so nicely on the grave physiological responses of corona on lungs, eyes, GI tract, guts, kidneys, and the brain. He nicely explained the receptor recognition mechanisms, pathways of cell entry of corona, and the various cross-species infections. We could learn a variety of things: the cascade of injury, the circadian and infection axis, the virus molecule interplay, anosmia, the enigmas associated with corona vaccines and therapies, targets of antiviral interventions, and many more. Our next speaker, Reverend Tapas Bhattacharjee, one of the most decorated civil service officers of our state, deliberated on the socio-environmental upshots of COVID-19 and the role of civic bodies, corporations, municipalities, panchayats, those who come as our prime saviors and rescue. He gave glaring and shocking case studies that bared our psychosocial limitations, mentioned about the series of grim economic pitfalls, domestic violences, COVID-induced policing, cyber crimes, and also elaborated upon wide range of civic, police, and judiciary redressal amenities that could be available at these shocking moments. Dr. Soumen, Reverend Professor of Kansas Medical Center, United States, truly enunciated the unwholesome realities of corona, the history of epidemics and pandemics, effects of corona on cell biology and cell physiology. He indicated the various trajectories of cellular backlashes and nicely portrayed various known and unknown affectations of different genres of coronaviruses, their causes and treatment options. But how far will be the zenith of suffering, or how deep is the nadir of infectivity? How far is the core of precision, and what, where, how, are still uncertain tales to tell. Even the new normal seems to bear the marks of kite flying. We are surely standing at the end of a precipice or a sharp cliff with bell of bathos ringing nearby. Who is inimical to whom, or whether I am inimical to myself, are endless questions that are difficult to solve by simple mechanical prescriptions. Some metrics indeed need to be developed on two parameters, infections and mortality, and then only the end game could be cited below the cutoff point. My heartiest thanks remains for Dr. Shormishta Chando, our faculty of Physiology Department and convener of the seminar committee, for shouldering the arduous task in moderating the entire show. I am deeply humbled by the relentless contributions of two of our young dynamic professors, Bholanath Pakira and Sheikh Jahiruddin, who, although on the backstage, are silently streaming the entire show without any technical hitch or glitch in communication system. The famous eco-novelist Ramchandra Guha, in his recent epic article, Where the Worlds Meet, has urged all of us for composing an international patriotic song to embrace global COVID sufferings. A wonderful flow of emotions indeed. The present restive situation shows us back to the timeless classic of Alice in Wonderland, where Lewis Carroll nicely sums up the secret to human survival by saying, we are actually moving faster and faster in order to remain standstill. So to survive every moment, we must learn to run fast as we can, like the honeybees. And if we wish to get anything more, we must run twice faster than before. Surely, to kill the virulent virus, we must learn to run very fast, very hard, to co-evolve with the natural systems, lest we perish in penury. So let us all wait for the divine ray and the drop of golden sun to bless us all for the long, long way to run. Good night, goodbye, and see you again and again in different walks of our life. Thank you. Over to Shormishta to continue, please.
Shormishta, please unmute your microphone.
Now we are entering